Night gathers over the quiet skin of a turning world, and the sky becomes a slow cathedral of distances. In that dark, an ember drifts in from a place without maps. It does not roar. It does not announce itself. It slides through the interstellar medium like a coal that has forgotten the fire that made it, carrying a chill so profound that it seems to drink starlight rather than reflect it. The heliosphere is only a thin veil before it, a boundary more symbolic than real. On the far edge, where the sun's breath thins to almost nothing, the ember crosses into a domain of sunlight and gravity. The story begins not with a trumpet, but with a hush. He is not here. She is not here. No human name sits upon its surface. There is only a relic, small next to planets, large next to dust, ancient next to us. It has wandered through a wilderness of gravity, wells, and tidal whispers, through magnetic murmurs and the quiet static of cosmic rays. Every centimetre of its crust is a palimpsest of encounters. Micrometeor impacts have written and rewritten its outer stones. Radiation has cooked new chemistry onto old grain. In its pores, ices wait like breath held in cold lungs. It is not alive, yet presence clings to it. It becomes impossible not to speak about it as if it were listening. The sun draws it inward, with a signature curve that belongs to no world bound to this star. The path is not a loop, but a crossing. There will be no return. That is how the geometry of its motion confesses its origin. It did not form here. It is not the child of our disk of gas and dust. It comes from distances where the night is different, from a cradle of elements that may have counted time in another rhythm. The curve is an accusation and an invitation. It frames a simple, unsettling question that will not stay quiet. Why now? There is a human tendency to imagine beckonings where there are only forces, to search for fingerprints inside the wind. Yet sometimes the wind learns a new accent, and the mind refuses to file it away as ordinary. The ember's timing pierces. It arrives in an era when eyes are sharper, when optics climb mountain air and digital images tick like patient hearts. It arrives when deep surveys sweep the sky in algorithmic arcs, when code is a second telescope, when a structure of watchers rings the earth with quiet persistence. It arrives when someone is ready to notice. The thought that it could be drawn by that readiness is a temptation, a small candle in a larger dark. The object itself remains indifferent. It keeps its vector. However, indifference can feel theatrical when it is framed by gravity and light. As the ember approaches the inner system, the star's pressure begins to work on it. A film of frost responds, grain by grain. Some molecules stir. The faintest coma begins to exhale. Where sunlight grazes a seam, a jet may blink into being, a whisper more than a shout, a breath too thin to hear. If dust lifts, it carries history in microscopic letters. If gas escapes, it writes chemistry into spectra that instruments can read. Every faint emission becomes a syllable, every frequency a small confession. The mind seeks meaning in these confessions. Nothing in them says purpose. Everything in them says origin. Ratios of carbon to oxygen, bands that belong to cyanide or hydroxyl, signatures of frozen carbon dioxide that outshout water in a manner few comets from our nursery have displayed. The facts may gather later, but the mood gathers now. It is the mood of a city at night when a stranger steps beneath a street lamp and simply stands there. No action. Only the fact of arrival, and the street suddenly feels like a stage. The ember's entrance alters the scene. This solar system feels observed not by eyes, but by the simple act of a passage that is not ours. A human mind cannot help it. The word called rises. Called by what? Called by whom? Perhaps nothing called it, and yet the sun is not innocent. A star curves space. The curve is a lens. Anything passing through that lens learns a new path. The lens does not decide. It persuades. The persuasion does not need intent. It only needs mass and time. In that sense, calling is a metaphor for focus. A traveller that might have missed us by light years is shifted by the geometry of 1,000 tiny tugs and one great pull. The result looks like an answer to a question no one asked aloud. The result feels like the consequence of an invitation the star wrote with gravity alone. Humans build instruments to push back against feeling, to give data a chair at the table, but feeling starts the dinner. Feeling keeps everyone seated while the first plates arrive. The ember's presence kindles a certain hunger that is hard to name. It is not only curiosity about chemistry and shape and spin, it is the ache for context, the ache for a wider village, a belief, held quietly and often with embarrassment, that the universe is not merely a museum of fossils, but a place where stories cross, where travellers leave traces of decisions made elsewhere. The ember awakens that belief in the careful and the skeptical alike, a brief softening at the edges of the rational voice. There is also humility in the air. Consider the age of what drifts in. Consider the arc of time that stretches behind it. When it formed, continents on this small planet may have been in other positions, or may not have existed at all. Suns are born and die in the span of its wandering. The galaxy rotates like a slow wheel, and this ember is only one spark among uncounted billions. That scale does not diminish the moment. It enlarges it. To be the place where such a path intersects light and measurement is a gift that requires nothing from us except attention. Attention is not passive. It is a way of welcoming. The welcoming takes many forms. There is the human urge to name. There is the human urge to plot and predict. There is the human urge to imagine. Each urge is a kind of offering. Each one says, in its own dialect, "Come closer, let us know you." On the surface of the object, none of that matters. Inside the human mind, it matters very much. The word called appears again, not as an accusation of agency, not as superstition, but as a poem about gravity and awareness. The sun writes an invitation in the only ink it owns. Instruments answer, minds answer. The ember seems to answer by arriving. The sky remains a patient stage. The faint streak thickens. The light of dawn begins to erase the view, but the image lingers in circuitry and in thought. It is possible to speak about rock and ice with tenderness. It is possible to listen to the near silence of a coma and feel as if something had addressed the listener by name. That feeling might be an error. It might be a bridge across which understanding eventually walks. Either way, the ember approaches, and with it comes a reordering of scale. The local becomes galactic. The everyday becomes cosmic. The small life now breathes a larger air. In that larger air, one question waits like a star low on the horizon. If a traveller can cross the void and pass through our neighbourhood, then the void is not an empty wall. It is a road. Roads suggest travellers. Travellers suggest origins. Origins suggest homes. The ember carries no flag. It requires no purpose. Yet the image of a road once seen does not vanish. Perhaps the simplest truth is also the most generous. Nothing called it. It is here because paths exist. The fact that paths exist is the most profound invitation of all. The rest is listening. Winter lies lightly on the foothills of the Andes, and the valley of Rio Hurtado holds its breath under a sky scraped clean by cold. The observatory domes rest like pale stones against the slope, each one a quiet hinge between mountain and night. Inside one dome, a 0.5-meter survey telescope waits with a wide glass eye and an appetite for motion. Its camera is a quilt of pixels stitched for speed rather than beauty. The plan for the night is simple and relentless. Sweep, shift, sweep again. The system does not admire constellations. It searches for the slight difference between one moment and the next, the thin line where change writes itself. The instrument belongs to a network that circles the world like a loose ring of lighthouses. Tonight, the lighthouse in Chile is the one that catches a flicker the others miss. At the console sits a night operator trained to trust the pipeline but still watch the stream. The air outside is steady. The seeing is kind. Between sequences, the software places a spoonful of silence, then moves the field by a careful cadence to paint a grid across the dark. The filters are broad and practical. The exposure times are short, because everything that could end the night is moving. The algorithm that follows each frame is a hunter with quick eyes and no vanity. Shortly before dawn on the 1st of July, 2025 local time, 4 frames of a certain field arrive in a cadence spaced for parallax and speed. Stars hold still in their old positions. One point does not. It is not a perfect point at all. It is slightly smeared, as if the sky had exhaled during the exposure. The elongation is real. not a finger of cloud or a tremor of mount. Subtraction against a deep template removes the background and leaves a thin echo of motion. The pipeline flags the echo as an unknown with non-sidereal rate and a profile just fat enough to whisper coma. The residuals are small. The signal to noise sits on the safe side of doubt, but not by much. The object moves neither like a main belt inhabitant nor like a near-Earth drifter. The rate and angle across the CCD suggest a visitor on a steeper approach, grazing the ecliptic at a slant that is indifferent to local lanes. The coordinates fall into the log with the raw honesty of fresh numbers. The operator does what habit teaches. Mark the candidate. Force follow-up on the next sequence. Ask the telescope to return to the same field after tasting the adjacent one. The second pass tightens the track. The smeared point repeats with the same stubborn place between frames, and the coma shape behaves like a memory trying to form. By the third pass, the tracklet is sufficient for a provisional motion vector. By the fourth, it is a seed for an orbit. Chatter in the control room remains minimal. The discipline is to let the pipeline breathe. The night is almost over, and dawn climbs the ridge with a pale knife. The telescope returns to safe home positions, and the data begin their second life in the electronic corridors they always walk. Within minutes, the candidate sits in the queue that will reach the confirmation boards watched by a worldwide constellation of telescopes and insomniacs. The machine-readable message contains nothing romantic. It lists astrometry. It lists magnitudes. It lists a rate and a direction that tell any experienced reader the same careful thing. This one is odd. As the day spills across Chile, telescopes in other longitudes take their turn under their own nights. A pair of quick responses catch the moving fleck where the first log said it should be, and the arc lengthens. With more points, the preliminary orbit code reaches for a solution that will almost certainly be wrong in detail and right in spirit. The eccentricity rises above the boundary that keeps family close. The barycentric fit leans beyond unity with a margin that grows with each hour of additional data. Hyperbolic is a word that requires patience. It becomes a conclusion only when hesitation is no longer the wiser path. The hesitation lasts just long enough to protect everyone from hope. The designation machinery begins its careful gears. A temporary cometary name appears for a moment, like scaffolding. Observers in Chile and beyond add photometry and refine positions. The coma proves shallow but persistent. The brightness fits a curve that does not belong to a fragment of hardware nor to an artifact. The pointing residuals stay well behaved, a sign that this is a single object with a clean enough head to be measured in the way comets have always been measured. The notice boards update. The forward integrations press the path inward toward a rendezvous with sunlight measured in months, not years. The backward integrations open like a fan into galactic space. Inside the survey building on that first morning, celebration is quiet. Coffee cools half-drunk on a desk. The operator rereads the logs with the private fear that a typo will undo the poetry that tries to form around the numbers. The fear proves unnecessary. Others have seen it too. The circuit has held. Messages arrive that read like confirmations of a meteorological front moving across a map. Here we caught it. Here too. The centroid sits where the predictors said, the trail looks the same in our frames. The variations in magnitude are within reason. The first faint estimates of intrinsic speed whisper that the object does not consent to be bound by the sun's field. The name that will carry into history appears after a sequence of formalities designed to replace enthusiasm with certainty. It is a simple naming, pointed and spare. It acknowledges the survey whose glass first found the smear. It places a numeral in front that speaks to rarity, not preference. It marks the object as a participant in a small and growing census of interstellar bodies that cross the inner lives of stars. The name fits like a bead on a string of quiet achievements that reach back through decades of patient skywork. The string is invisible to most eyes, but to those who spend nights in control rooms and domes, it glows. How it was found can be told without romance. A wide-field instrument measured the sky. An algorithm compared frames and searched for new motion. A tracklet crossed a threshold set by engineers who once argued in rooms about false positives and missed chances. A human watched without blinking and asked the telescope to look again. Mathematics shaped the raw positions into a path, then into parameters that described the future with practical precision. Telemetry travelled along cables. across routers, through agencies that exist mostly as addresses on the internet and friendships at conferences. The result is a clean entry in a catalogue and a small storm in the hearts of those who care. Where it was found matters because the land lends steadiness the way a tripod lends stability to a hand. The valley air above Rio Hurtado often arrives dry and laminar, the kind of atmosphere that lets stars sit on the sensor like coins on glass. The mountain hugs the dome against the worst of the wind. The distance from city lights is measured in dozens of kilometers. The southern sky opens in a geometry that complements sister telescopes elsewhere on Earth. When the network works, the planet itself rotates the baton from one site to another. That night, the baton began in Chile, and the first note played clearly there. When it was found, is less a clock time than a readiness. It happens after new circuits were installed, after software learned to separate smears made by optics from smears made by motion, after the team tuned thresholds to fish in deeper waters without catching every ripple. It happens during a winter when other instruments on other continents were in their own seasons, sharing duty to make coverage more complete than a single site could ever offer. It happens at an hour when most of the world is lost in sleep or listlessly paging blue screens. The click that sealed it into memory was the quietest possible. It was the sound of someone pressing save. Who found it is a line that resists shrinking to a single name. A survey discovers by the cumulative labor of many hands, some of which never touch the telescope. Lens makers count, coders count. People who argued about the shape of the dome count because airflow changes seeing. An operator in a small chair counts because a finger moved a field back into view when it might have been allowed to slide away. Each person in that long chain earns a syllable in a collective who that does not fit neatly on a title card. The system prefers to speak of the network rather than the individual. The object will carry a team's name because the work itself was a chorus. The record of this night reads plainly in the archival entry: coordinates, times, magnitudes, station codes. The prose that rides above those lines is something the entry does not preserve. It lives in the way a control room smells before dawn, in the way sunlight looks when it first finds dust on a floor after a successful night. It lives in the silence that follows the first notification, a silence that is not empty but full, like the pause after a held breath. The discovery is not the end of anything. It is the beginning of a long listening. The telescope closes, the valley warms. Far above, the object walks its line toward a star. It did not grow around. A moving mark now traced in the ledger of human attention. A new numeral enters the cosmic ledger, and with it the quiet weight of pattern. The designation is austere, a single letter joined to a number, followed by the name of the survey that first noticed a smear where the sky had been clean. The letter stands for interstellar, the number for the order in which such travellers have been confirmed, the name for the human eyes and instruments that caught it. 3 is a threshold that changes how minds measure rarity. 1 can be an accident, 2 can be a rhyme, 3 begins to sound like a chorus, faint but distinct against the background of ordinary comets that rise and fall with the seasons of a single star. The earlier arrivals shaped expectations in opposite directions. The first presented as a bare shard, light suppressed by a colour that hinted at radiation-baked organics, rotation irregular, non-gravitational drift, measured in millimeters per second squared yet persistent, all without a detectable veil of gas. The second looked like a textbook comet written in a script not from this system, dust-bright, gas-abundant, a nucleus that shed fragments as sunlight heated its skin. They were so unlike one another that together they widened the category to the point of awkwardness. Visitor became a term that said more about origin than about appearance, a reminder that nature cares little for tidy bins. The third visitor steps into that widened room and deepens it. It shines with a modesty that refuses spectacle, yet its chemistry whispers a balance that many local comets do not share. Water does not immediately lead the dance. Carbon-bearing volatiles announce themselves with confidence, a signal that is not unheard of, but that challenges the expectation that solar system ice is the default template for all frozen worlds. This is not a contradiction of those earlier lessons. Rather, it is a new axis on which to spin the globe of possibility. Composition becomes a compass that points back toward the climate of birth, not a label stamped by proximity to our own star. Naming matters because the act of naming draws a boundary around a phenomenon and invites theory to live there. The The title 3I tells astronomers that a small population is now real enough to model not only as legends but as statistics. Flux through the inner system can be estimated with less bravado and more humility. Survey yield can be forecast in terms that affect staffing, telescope time, and the risk tolerance of follow-up programs. The third entry sharpens those estimates. It says that searches are not only lucky, they are competent. It says that the sky holds more spindrift from other suns than old intuition allowed. The path across the sun's gravity gives the essential proof. A hyperbolic orbit is a sentence written by energy balance, and the third visitor speaks that grammar clearly. Its speed at infinity belongs to distant birth, not to any slingshot within our family. That speed brings with it a subtle gift. It means that the object has sampled many gravitational neighborhoods, each with its own tides and histories, and has survived the long abrasion of time between stars. Survival implies cohesion, at least enough to carry memory in the form of minerals and ices. Memory implies that telescopes can read a portion of that history in light, and laboratories can frame experiments to echo it. Perception shifts when a count becomes 3. The night sky used to feel sealed at the edges, as if comets and asteroids belonged to a closed loop of leftovers from a single disk. The first breach cracked that seal, the second made the crack permanent, the third allows a new map to be drawn. On that map, the inner system is not a cul-de-sac, but an intersection on a larger road where dust, stones, and ice from unrelated nurseries pass through at a rate that can no longer be dismissed. The romance of isolation yields to the realism of traffic. Sparse but steady, along lanes set by galactic dynamics rather than by local tradition. Comparison is useful, though it is a careful art. The first visitor appeared dry, perhaps cloaked by a rind that resisted direct heating, perhaps venting through pores instead of fountains, perhaps shaped into a thin geometry that complicated the way reflected light told its story. The second wore a coma so frank that it could be studied as a comet without apology, its tail a banner of simple sublimation. The newcomer does not mimic either one. Its spectrum outlines a different hierarchy of volatiles, a sort of cuisine learned in a colder kitchen or cooked under other elements of stellar light. The triad that results is not a spectrum with 2 poles. It is a triangle with a depth that begs to be filled by many points. Culture within astronomy evolves with such arrivals. The tools that once considered interstellar capture, hypothetical now consider interception, rendezvous, and close reading. Proposals grow bolder, because a third detection lowers the chance that a special mission would launch into a famine of targets. Algorithms for surveys revise their priors, promoting candidates with steep motion angles or disobedient brightness curves that older software might have dismissed. Even language changes. Words like guest, visitor, immigrant, and messenger emerge in colloquy, not as metaphors that erase physics, but as reminders that origin carries meaning beyond orbital shape. This change in language hints at a deeper shift. The third visitor encourages a view of the galaxy as a place where the leftovers of planet building wander widely, carrying information in unintentional capsules. Each such body is a sampling probe flown by chance and delivered by gravity, indifferent to being read yet perfectly legible under the right light. That indifference is a relief. It allows minds to treat the event without the pressure of intention, to find wonder that is safe for skepticism. The wonder lies in the idea that materials forged in alien light can outgas within reach of instruments that know how to listen. Rarity remains. 3 is still small, and nature loves to surprise with long pauses. Yet rarity now feels habitable. Time stretches ahead, with the promise that future entries will populate a scatterplot where trends reveal themselves. Will most visitors wear comae rich in carbon dioxide? Or will this third prove an outlier, a relic from a domain that contributes only a thin trickle? Will sizes cluster near modest values that surveys can catch? Or will selection bias hide a population of giants and grains that only different methods can reveal? The third entry does not answer. It furnishes the questions with handles that can be gripped by design rather than by fantasy. Identity flows from such framing. The object is neither an omen nor a threat. It is a sample that denied isolation, arrived with enough grace to be measured, and will leave without apology. In the brief window of closeness, reflection about what it means to be the third carries its own gravity. It pulls efforts together that had been scattered across subfields. Solar physicists care because sunlight writes on alien ices. Dynamicists care because the approach route contains memory of a galactic orbit. Chemists care because unpredicted ratios hint at processes poorly represented in models derived from a single system. Instrument builders care because performance at the edge of sensitivity is suddenly the center of the story. Expectation resets. The idea that an interstellar object must look like a comet or must look like a bare rock now gives way to a broader patience. The new default is variety, bounded by physics but adventurous in expression. With that patience comes a sober resolve to avoid declaring anomalies extraordinary before they are even understood. Extraordinary has a way of shrinking as instruments improve. The third visitor trains the eye to watch for simple explanations that are not simple at all, such as seasonal sublimation through a crust that favors certain molecules, or rotational states that turn a nucleus into a complicated lighthouse of thermal response. The presence of this new point in the catalogue also folds the human story into an interesting shape. Surveys were funded to protect, to monitor, to study the population of local bodies that can collide with worlds. In performing that guardianship, they also opened a window on the interstellar. Protection and curiosity turn out to be siblings. This siblinghood gives the third visitor a role in the civic imagination. It justifies stamina in programs that might otherwise be seen as routine, and it provides a reminder that practical work often creates room for wonder without planning to. At a human scale, nothing changes. Mornings still arrive, seasons still turn, obligations still ask for hands and hours. At a cosmic scale, a small threshold has been crossed, and in the language of thresholds, this one is quiet, like a footstep on a leaf. The sky now feels slightly more porous. The third visitor has made that permeability tangible, not by drama, but by presence, and by the clean honesty of numbers that refuse to be bound. With that honesty comes the privilege of looking outward and thinking inward, a symmetry that science loves to cultivate. Velocity is a kind of truth that light cannot disguise. Against the sun, every traveller carries a signature written not in colour but in energy. The test is old and merciless. Take the speed, square it, halve it, then subtract the pull of the star at that distance. If the result is negative, the traveller is a subject. If the result is 0, it stands at the border. If the result is positive, it is a passerby. In symbols, the sentence is short. Specific energy equals v squared over 2 minus mu over r. A positive value says the same thing in every language of mechanics. It came from elsewhere and will go elsewhere again. The shape that belongs to such an energy is a hyperbola. Where ellipses close and circles repeat, a hyperbola crosses. Draw it as a swoop that approaches, swings, then leaves, with the sun pinned at one focus like a knot on a string. Far from the star, the path approaches a straight line called the inbound asymptote. Far beyond the swing, it exits along another line called the outbound asymptote. The angle between those lines is the deflection. In a world governed by inverse square gravity, the size of that bend is exact. It equals twice the arc sine of 1 over the eccentricity. Eccentricity larger than 1 means the bend is small. The faster the visitor, the straighter it goes. Numbers are not guessed. They are measured in the small grammar of positions on the sky. A camera takes a frame. Minutes later, it takes another. The small shift between the two, combined with the known rotation of Earth and the parallax that comes from a moving observatory on a spinning planet, becomes a velocity in the sky plane. Fold in the timestamps. Bring in a third and a fourth night. Solve for the path that best fits all those points weighted by their uncertainties. What begins as a set of dots quickly hardens into an orbit, whose parameters carry error bars like soft shadows. As the arc grows long, the shadows shrink. Eccentricity fights to reveal whether it is less than, equal to, or greater than 1. There is a trap in early days. Comets exhale. Gas and dust apply a force that does not come from gravity. That force can mimic a push that makes the path look more open than it truly is. Responsible work avoids premature declarations. Positions are modelled not as points from a perfect nucleus, but as centroids of soft comae that drift with seeing and wind. Instrumental distortions are calibrated with star fields that have already told their truths to larger telescopes. When the models include small, non-gravitational terms, and the orbit still prefers positive energy in a frame centered on the Sun, attention turns to a stricter test. That stricter test moves the frame. The planets are busy sculptors. They tug, and their tugs can fool the heliocentric calculation when the traveller is still near them. To remove their artistry, the orbit is transformed to a barycentric view, with the origin at the centre of mass of the entire system. In that quieted frame, the long-term energy assumption holds better. The eccentricity that decides the verdict is read there. If it remains above unity with comfortable margin, the path is not a disguised long-period ellipse. It is an interstellar crossing with speed at infinity that can be written on the page as a simple v with a small index. That number carries history. It is the remnant of distant motion untouched by our neighbourhood. Speed at infinity is not only a label. With it, one can compute the strength of the star's persuasion. The characteristic energy, C3, the square of that speed, tells how much room there is for deflection or for bending by planets. Given a perihelion distance and that energy, the expected swing is fixed. If a giant planet lies near the path, its sphere of influence can add a twist to the geometry, changing the outbound direction by a little or by a lot. Close analysis searches for such encounters in the calendar of the object's approach. Predicted distances to Jupiter, Saturn, or even Earth are examined like weather, because a single near pass can flick the outbound line into a new quadrant of the sky without changing the essential fact that the visitor is free. The sky reveals the approach direction as a radiant, the point from which the motion seems to come when projected backward. After removing Earth's own motion and placing the velocity in the Sun's frame, the radiant becomes a clue to the visitor's galactic path. Transform again into a frame that rides with the local standard of rest, the averaged motion of nearby stars, and the velocity becomes a vector with a small excess or deficit relative to that common swirl. Some arrivals align near the apex toward which the Sun moves around the galaxy. Others do not. Either way, the number suggests a neighbourhood of stellar speeds from which such bodies might be launched by the slow mechanics of planet formation and the quick violence of distant encounters. Capture is a word that tempts the tongue but has no place here without friction. Gravity alone cannot keep what arrives with positive energy. The Sun can bend. It cannot own. For capture to occur, energy must be removed by some break, a collision with a planet, a deep plunge through a planetary atmosphere, or a tidal shredding that leaves fragments to share the lost motion among themselves. In the clean vacuum of space, those breaks are rare. The typical fate is passage. The star lends brightness and heat for a brief season. Then the traveller departs with the same energy it carried in, coloured only by a small rotation of direction imparted by the symphony of masses it has threaded. Radiation pressure receives its own paragraph because it whispers into orbits in ways that inaccurately measured astrometry can misread. Photons pushing on dust grains change the centre of light, not the centre of mass. Small pieces can sail. Large nuclei tend not to care. When analysis constrains the area to mass ratio tightly and still finds that the path insists on an energy above zero, confidence grows that radiation itself is not forging a false hyperbola. The coma can be modelled and subtracted. The remaining motion still confesses freedom. Perihelion is the moment the mathematics lives for. There, the velocity against the Sun peaks. There, the vector components switch their hierarchy from inward to outward. A clean set of measurements straddling that moment erases many ambiguities. Before perihelion, modellers worry that outgassing forces might aim inward and bias the fit. After perihelion, new data make it possible to solve for those forces explicitly. If the energy stays positive in both arcs and in the combined fit, the conclusion becomes a plateau rather than a spike. The identity as an interstellar crosser is not an announcement. It is the residue left after every alternative has been sanded away. Deflection itself invites a geometric meditation. The angle is small for fast visitors and grows as speed at infinity shrinks. A traveller that barely clears the escape threshold can be turned almost back upon its inbound path, thrown into a dramatic curve that wraps around the star like a ribbon. A traveller with a large surplus passes in a low bow, barely nodding as it goes. The third kind, intermediate, offers the best canvas for change. Planetary conjunctions near perihelion can add or subtract a handful of degrees to the outbound direction, enough to send observers along new lines of sight if they hope to follow it to great distances. The statistical tools behind these statements hide inside words like covariance, residual, and formal error. They matter because velocity against the sun is not measured by a single stopwatch but inferred from many small slivers of information woven together. Each reported position carries a reported uncertainty. Each model step propagates those uncertainties forward to the orbital elements. A result written as eccentricity equals 1 point something without an error bar is a promise made without context. The context is the cloud of plausible orbits that surround the best fit. When that cloud sits entirely above unity in the barycentric frame, the label interstellar is not bravado. It is simply careful speech. All of this mathematics returns to a simple picture any schoolchild could draw. A curve comes in from far away, curves a little, and goes out again. Against the sun, velocity speaks whether a path will close or not. In the quiet of that determination lies a sensation both technical and tender. A free path means a traveller that carries an untouchable past and an untouchable future. The star is a pause, not a home. The numbers do not dull the feeling. They grant it structure. They make the intuition precise enough that telescopes can plan exposures and instruments can tune their expectations to the brief season of brightness that such a crossing allows. In the end, the speed is not a boast, but a biography written compactly. It carries the memory of the cradle in which the body formed, the kicks and nudges that sent it into the wild, and the long cruise through a medium too thin to slow it. The sun reads that biography not with welcome or dismissal, but with a curve. The curve answers a single question, with quiet finality, bound or free. The answer illuminates everything else that follows. The first measurements sharpen rather than soothe. At a distance where water should begin to speak, the spectral lines that belong to water stay hesitant while carbon dioxide rises with confidence. The band near 4.3 micrometers strengthens like a steady pulse. The band near 2.7 for water flickers, as if behind frosted glass. The ratio violates easy habit. In familiar comets from the local cloud, water often leads the chorus and carbon follows as harmony. Here the harmony tries to become melody. Temperature alone cannot explain it. Sunlight provides enough energy to lift water from a porous skin. Yet the chemistry seems to choose another door. A look at the dust makes matters stranger. The coma measures as thin but persistent, and its shape is not centered as politely as models prefer. A fan appears to one side, then shifts, then fades. The AF rho parameter, that simple proxy for dust production beloved for its convenience, refuses to match the gas production inferred from carbon dioxide. Either the grains are large and few, or they are small and sticky, or they carry optical properties outside the comfort of tables drawn from local precedents. Color indices wobble between neutral and slightly red, with a phase angle dependence that feels unfamiliar. The numbers allow several tales, none graceful. Thermal models are summoned to tame the noise. They ask for a beaming parameter, a way to describe how roughness and rotation throw heat into space. Values that fit the brightness at one epoch fail at another. A single smooth nucleus cannot be made to behave. Introduce facets, introduce shadowed pits, introduce a skin of low thermal inertia wrapped around pockets of higher inertia, and the fit improves for a night or two. Then a new set of photometry arrives, and the room tilts again. The size of the nucleus retreats behind a curtain of degeneracy. A small dark body with a hot surface can mimic a larger, cooler one with a paler face. Albedo becomes a rumor. Rotation should help, yet rotation abandons clarity. The light curve breathes with amplitude, but denies a single period. Peaks arrive, then arrive a little late, then arrive doubled, as if two clocks were speaking at once. This is the signature of a body not rotating around a single principal axis. Torques from jets, even weak jets, can push a nucleus into a tumble that resists simple periodicity. Non-principal axis states are not exotic. They are simply inconvenient, and they turn every attempt to associate surface features with sunlight into a hall of mirrors. Orientation drifts. The distribution of heating slides in ways that render clear cause and effect thin. Non-gravitational acceleration lurks as a delicate subtraction problem. Remove planetary pulls, remove the pressure of sunlight on dust, remove the bias that comes from measuring the center of light rather than mass. What remains is a whisper of force that points neither consistently away from the sun nor consistently along velocity. The direction bends with the season of the object's path. If jet geometry changes with obliquity, such bending is natural. If the source is deeply buried and vents through occasional cracks, the bending grows chaotic. Parameterized fits recover a small A1 or A2 term with uncertainties that refuse to shrink to comfort. The temptation to anchor meaning to those terms must be resisted. They are weather, not climate. Ionized gas should draw a clean map of interaction with the solar wind. Yet the standoff distance of the bow wave inferred from narrowband imaging does not neatly match production rates derived from carbon dioxide. Either the ionization times are different than assumed because of local wind conditions, or the geometry of outgassing concentrates flow into sectors that make a point measurement misleading. Charge exchange emissions flicker in step with the wind's own rhythm. Instruments built to hunt steady states must learn to sing with a drummer whose tempo wanders. Polarimetry adds both beauty and trouble. The fractional polarization of scattered sunlight as a function of phase angle sketches a curve that sits offset from the textbook line. Such an offset hints at dust grains that are more compact or more evolved, or coated with organics that changed their surface microphysics in a long bath of cosmic rays. Processed dust would be no surprise for a traveler that has crossed interstellar gulfs. What surprises is the combination of processed dust with a coma whose gas budget leans so hard on carbon dioxide. A crust that resisted thermal evolution might be expected to protect water more than it protects carbon dioxide. The measurement argues the opposite. Sodium leaves a faint signature where many comets show a bolder one. Cyanogen is modest but present. Hydroxyl waves between detectability and denial. Each of these small facts is plastic. Each can be bent to fit narratives of formation at different frost lines, or of irradiation that fractionated volatiles, or of mantles that sieve gases by molecule size and passage geometry. The trouble lies not with possibility but with exclusivity. More than one story can explain the lines. The universe seems to tolerate several kitchens that cook bodies into similar flavors by different recipes. Searches for fragments reveal nothing obvious. The nucleus does not shed a family bright enough for even generous eyes. That silence could mean strength, or it could mean that shedding occurs below the comforting limit of detection in chunks that camera systems would blur into the coma. An outburst would be the clarifier, yet outbursts refuse to stage themselves on cue. Minor brightenings show in the records. They are small. They arrive when rotational models would not expect insulation to peak at an active area. They hint at pockets of pressure burrowing under the skin until a seam gives way along a weakness written long ago. Perihelion waits like a test, but even before that moment, the direction transformed to the local standard of rest provides another kind of thorn. The relative speed is close enough to the neighborhood, mean that one can argue for common birth conditions anywhere in a wide band of the galaxy. This is statistically comfortable and narratively unsatisfying. Had the speed been very low, capture by the sun could have flirted with possibility under special circumstances. Had the speed been very high, formation in an unusual gravitational nursery would have announced itself. Instead, the number sits in the middle, unwilling to break symmetry. A careful mind inspects the possibilities that grow in the shadow of uncertainty. A thin crust made of refractory dust could allow carbon dioxide to reach the surface through fractures that water cannot widen at current temperatures. Cosmic rays over millions of years could have cracked complex organics into a film that favors the escape of smaller carbon molecules while clogging paths for heavier or stickier ones. An insulating blanket could build a pressure cooker, venting from depth through a limited set of throats that aim the flow and sculpt the coma into transient fans. Each idea admits testable predictions. Each prediction demands a fidelity of observation that strains against the signal. Models of nucleus shape can be coaxed from the way the light curve morphs with phase angle, yet every inversion rests on assumptions about albedo patterns that may be false. A contact binary can masquerade as a single lumpy body. A small swarm bound by weak gravity can mimic a monolith if the swarm is tight and the cadence of the data fails to catch the subtle mutual eclipse. Radar would silence many of these ghosts, but the range is brutal. and the cross-section too small for anything except heroic attempts. The chemistry also tempts an origin story that points toward a cold birth beyond a distant carbon dioxide snowline. That clean inference stumbles when one remembers that disks around other stars can be hot in odd places and cold in others, that metallicity can shift the pasture where ices graze, that the migration of giant planets can shuffle reservoirs until nursery memories dissolve into a mosaic. Spectral lines give the melody, not the map. Isotopes would anchor the map. The lines are too faint for isotopic ratios that would settle long arguments about heritage. Even gravitational context offers a split tongue. The inbound radiant aligns near a region of the sky that contains streams of stars from different galactic substructures. One label suggests the thick disk, older and more metal poor. Another label points to the thin disk, familiar and younger. Proper motion data for nearby stars allow both. One can tie the vector to a population of ejected debris from planetary systems not unlike the Sunday. One can also argue for bodies born in colder, older neighborhoods where carbon chemistry might claim priority in the freeze. Minutes turn into nights, and the error bars shrink with admirable discipline. Paradoxically, the story grows larger. Each improved parameter removes one ghost and reveals two more standing behind it. The brain hungers for a single line that threads the beads into a necklace. The sky answers with a handful of lines that cross without knotting. The mystery does not expand through theatrics. It expands through the steady refusal of the data to choose one interpretation and dismiss the rest. The discipline now is patience shaped by design. Instruments adjust their filters to emphasize the bands that matter most to the controversy. Telescopes coordinate to catch the same secular behavior at different wavelengths. Observers plan a cadence that can distinguish rotation from outburst and outburst from geometry. The traveler continues to offer light and gas in quantities just large enough to keep the conversation alive. Explanation waits at the edge of the field like a figure in fog. The mind can see the outline. The details will not resolve. A map of the galaxy opens with quiet clarity. A thin disk shines where young stars sketch spiral arms in punctuated blue. Above and below that plane floats a thicker sheet of older suns, their orbits puffed by ancient violence and their chemistry tuned by earlier epochs. Farther out still drifts a sparse halo of remnants and stories. Each component holds a tone in the long chord of the Milky Way. The thicker sheet carries a sound like worn bronze. Its stars lag slightly behind the swirl of the thin disk, lean toward higher orbits above and below the plane, and keep memories written in oxygen-rich, metal-poor language. In that sheet, planets once formed around suns that were themselves survivors, and fragments from their nurseries learn to travel wide. Kinematics can summon that sheet from a single vector. The inbound path of an interstellar body can be translated into the motion components astronomers write as U, V, and W, pointing toward the galactic center, forward along galactic rotation, and up out of the plane. The transformation is a ritual that scrubs away the reflex motion of Earth and the local pull of the Sunday. What remains is a velocity in the larger room of stars. A modest lag in V, a generous vertical component in W, and a dispersion-like flavor in U begin to whisper the dialect of the thick disk. The whisper does not announce identity. It invites association, the way a regional accent hints at an upbringing without naming a town. Actions and integrals of motion give the idea a spine. In a smooth galactic potential, angular momentum about the center, the vertical action, and the radial action serve as conserved quantities over timescales longer than a single pass through a planetary system. Trace the visitor's line backward while letting it feel only the overall pull of the Milky Way, and its momentum aligns more naturally with orbits that spend part of each cycle above the crowded plane. Such orbits are comfortable residences for thick disk stars. They are paths with larger scale heights, older ages, and metal abundances written a bit below solar. A small ice-bearing remnant launched from such an environment would inherit these kinematic habits as faithfully as a seed carries shape. Age marks the thick disk with a long, slow pen. Many of its stars count time near 10 billion years. Their atmospheres wear alpha elements like old jewelry, with oxygen and magnesium enhanced relative to iron, a signature of quick enrichment by supernovae that burned rapidly in the galaxy's youth. Protoplanetary disks around such stars would have grown in a climate with fewer heavy elements overall and less dust per unit gas. Opacity changes when dust thins, so the furnace within those disks would have vented heat differently. Snow lines for common volatiles would have shifted. The water condensation frontier, the carbon monoxide frontier, and the radius where carbon dioxide builds on grains could all slide compared with the architecture common around younger, more metal-rich suns. Chemistry follows those fronts with obedient subtlety. On grain surfaces, carbon monoxide can oxidize into carbon dioxide when oxygen is present, and ultraviolet fields and temperatures cooperate. Where dust abundance and ultraviolet penetration differ, reaction rates and grain temperatures drift. In a disk with reduced dust, ultraviolet light from the star reaches deeper. In a disk with lower metallicity, cooling runs along other rails. Laboratory work and astrochemical models show that, under certain regimes, carbon dioxide becomes favoured on or within grains, while water remains locked deeper until heating grows more intense. A small body assembling in such a nursery could trap a higher fraction of carbon dioxide relative to water within its matrix, particularly if porous aggregates shield water behind refractory skins that later behave as valves. Dynamical architecture also shifts in that older population. Giant planets, if present, may have formed more slowly or with different mass budgets. Migration pathways would interact with disks of different viscosity and opacity. Stirring of planetesimal belts could be harsher or gentler, but small bodies would still cross resonances, be scattered, and sometimes be ejected entirely. The mechanism of ejection does not care about era. A close pass by a growing giant flings a fragment beyond escape. In a system with a higher vertical excursion around the galaxy, ejected bodies find themselves launched into neighborhoods where stellar tides and molecular clouds are sparser, allowing long, undisturbed cruises that preserve delicate surfaces. Irradiation along those cruises paints its own layer of history. Above the plane, where shielding by dense gas is reduced, cosmic rays and interstellar ultraviolet fields work patiently. Organics on grain mantles brown into complex films. Volatile pathways inside pores are reworked. Carbon-rich residues build skins that are thin yet influential. Membranes that can throttle the escape of certain molecules when starlight later wakes the ice. If carbon dioxide moves through such treated skins more easily than water, either by diffusion or by fracture chemistry, an approaching star will read the mix as a bias. The emission lines will favour carbon dioxide even when water is present in abundance beneath. The bias becomes a fossil of long exposure in a corridor familiar to thick disk travellers. Population statistics sharpen the intuition. The thick disk rotates a little behind the thin disk, often by a few tens of kilometres per second. Its velocity dispersion is larger, with vertical motions that reach well beyond the gentle oscillations of young stars. A random sample of interstellar fragments should mirror that spread. Some will arrive from directions that betray high inclinations relative to the plane. Some will carry speeds that echo the rotational lag. Individually, each object is a poor witness. Collectively, their velocity cloud will sketch the silhouette of origins. A visitor whose vector rests comfortably inside that cloud becomes a plausible emigrant from older stock. There is also a geography of ejection that favours persistence. In the thin disk's crowded midplane, gravitational nudges from passing stars, giant molecular clouds, and the long arms of spiral density waves are frequent. In the thicker strata, visitors survive longer between strong perturbations. They fall through the plane and rise again like quiet pendulums on galactic scales. Each cycle preserves direction with only slow diffusion. A fragment set free billions of years ago can still carry the flavour of its home without losing the trail entirely. Composition becomes a secondary compass, more fragile but still suggestive. Lower metallicity does not mean a lack of carbon or oxygen. It means fewer heavy atoms per hydrogen and helium, and a different timeline for the appearance of dust nuclei. If oxygen enrichment relative to iron is common in the thick disk, then grain mantles could grow in oxygen-friendly conditions early, making carbon dioxide formation efficient wherever temperature allows. Later, as disks cool and evolve, water takes its durable seat. A body assembled from layers during this evolution may bake out carbon dioxide preferentially when modest heat returns, while leaving water masked until stronger insulation or deeper cracks appear. Ejection ages make a final, sober argument. Thick disk systems have simply had more time to launch debris. Over billions of years, the attrition of fragments from many planetary systems builds a low-density river of solids that drift between stars. Younger populations contribute too, but their integrated output so far is smaller. A traveller plucked at random from that river is statistically more likely to be old than young. It carries a bias baked into the galaxy's calendar. The bias is gentle, not a verdict, yet it leans the mind toward elder neighborhoods when an interstellar crosser is measured without contradiction toward that conclusion. Testing these inferences asks for patience and precision. Kinematics can be refined until the membership likelihood in a thick disk population can be stated with honest probabilities. Backward integrations under modern galactic potentials can reveal whether the trajectory samples regions where thick disk densities dominate. Spectroscopy can search for subtle fingerprints that align with early chemical environments, such as relative strengths of bands shaped by grain growth histories, or faint traces that correlate with high oxygen to iron regimes. None of these alone would close the case. Together they build a pattern that the eye can recognize before the tongue dares to name. The picture that forms is not a proclamation. It is an aroma caught on a breeze. An interstellar body arrives with a motion that sits comfortably inside the choir of older orbits. Its probable birth was in a disk lit by a star that forged its metals when the galaxy was still learning its current shape. Its chemistry bears the quiet influence of that childhood. Its surface holds varnish from long seasons spent in less crowded lanes above the plane. Nothing miraculous attends this provenance. It is simply one of the many ways the Milky Way moves matter, from cradle to wilderness, and from wilderness to unwary observers who wait with spectrographs and patience. Intent is a magnet for the human mind. When a rare arrival crosses a familiar sky, meaning reaches out before measurement does, and a question gathers in the throat of reason. Was this passage summoned, or is it one more stitch in the wide fabric of chance? Physics asks for a slower ritual. It places the idea of calling beside the idea of coincidence, and weighs them with tools that perform better than instinct. The stage is not morality, but mechanics. The decision is not a verdict, but a balance of likelihoods. Signal detection offers the first frame. One hypothesis says that visitors arrive as a Poisson rain from the galaxy, indifferent to local calendars. The competing hypothesis says an arrival was timed or aimed. If the base rate of random crossers is small but non-zero, long watches will still witness them. The mind that forgets the base rate falls into the trap of surprise inflation, reading intent from scarcity. Bayesian language cures the dizziness. Start with a prior for agency so tiny that it honors all the empty centuries. Update that prior with the evidence at hand. Unless the evidence contains structure that random flux cannot mimic, the posterior for intent remains small enough to vanish inside the rounding error of honesty. Selection effects sharpen the caution. Instruments are now deep, wide, and persistent compared with earlier eras. Surveys revisit the same fields, with cadences crafted to catch motion, and automated pipelines sift for faint smears humans would miss. The Earth also sits at a time in its own story, when a global network splits the sky among nights and seasons, planting watchers at many longitudes. The coincidence of capability and encounter can look like choreography. It is not. It is the mathematics of detectability. If rain falls steadily but an umbrella is raised only this year, the life beneath that umbrella begins to notice, drops it once ignored. It is tempting to mistake readiness for invitation. Gravity writes the second frame. A star bends paths even when it does not bind, and the bending acts like a focusing lens that concentrates trajectories near the well. The cross-section for passage increases by a factor that depends on speed and the depth of the potential. The formula is old, a circle enlarged by 1 plus the escape term divided by the square of the incoming speed. The result is simple. A fast object barely notices. A slower one finds its lane widened. If the galaxy supplies a spectrum of speeds, the Sun prefers to greet the slower end by pure geometry. That preference looks like beckoning only if the mathematics behind it is hidden from view. Liouville's theorem adds moral clarity to the optics. In a smooth potential, the density of trajectories in phase space is conserved. No lens can conjure travelers from emptiness. It can only rearrange their directions and concentrate them briefly. Calling dissolves into curvature. The sun does not choose. It persuades equally in all directions allowed by energy and impact parameter. The persuasion is lawful, blind, and sufficient to explain an increase in encounters without invoking purpose. Galactic kinematics provides the third frame. Stars drift, shear, and bob in their orbits around the center, and the material ejected from their planetary systems inherits those motions. Flux at any star depends on its velocity relative to the local river of debris. When a star approaches the apex of its motion through that river, the relative wind changes. The distribution of encounter velocities tilts. Over tens of millions of years, passages through spiral arms and encounters with clouds modulate the density of loose stones between suns. None of this singles out a particular world. All of it structures the probability that someone on a particular world with a particular telescope will write the date of a sighting into a log. Energy accounting polishes the skepticism about agency. To aim a 100-meter rock across interstellar space requires a change in velocity that dwarfs the chemical budget of a small civilization. Even with gravitational assists, the steering must be exquisite, the timing precise over centuries, and the uncertainty in planetary positions accounted for with margins that are not forgiving. The cost in joules climbs with every kilometer per second of correction. A distant intelligence could own power sources that make such costs trivial, but power does not solve targeting noise or collisions along the way. The argument does not forbid agency. It pushes the prior lower still. If calling were real, it would leave fingerprints that random dynamics struggle to counterfeit. Intent compresses entropy. It prefers low-complexity patterns that can be recognized across cultures and epochs. A messenger might arrive on an anniversary meaningful to a probable audience, or align itself with the focal line of the sun where general relativity turns starlight into a crude but magnificent telescope, or modulate its spin and activity with prime intervals that spectroscopy could decode. Patterns like those translate into a surplus of mutual information between the object's behavior and the observer's expectations. Noise will occasionally mimic simplicity, but not repeatedly, and not across independent channels. The solar gravitational lens is worth a meditative pause. Beyond roughly 550 astronomical units, the sun focuses light from a distant source onto a line where an instrument could drink a torrent of magnified photons. A deliberate caller who knew this fact might aim hardware toward that line, using the star itself as a relay. The geometry of such a move is unforgiving. The alignment must be astrometric poetry. A natural body that wanders through those same coordinates would be a coincidence of extreme order. But coincidences of extreme order do occur given enough trials. Without a tight alignment and a signature payload, the simple hypothesis remains the mature choice. Statistics can be made intimate by parables. Consider the birthday puzzle, where a group of people in a room needs only a few dozen members before shared birthdays become likely. Human intuition stumbles at this because it scales linear expectations into combinatorial worlds. The sky offers a similar trick. Out of countless patches and cadences, out of many baselines of time, out of arrays of instruments, some alignment of arrival and awareness will always feel uncanny. Awe is a proper response. Attribution is a separate labor. None of this abolishes wonder. Wonder changes its clothes and stands taller. A universe capable of orchestrating such precise courses with gravity alone is already richer than any fable. In that universe, meaning can be found in the patient recognition that physics writes hymns without words. Intent may yet enter the story, but if it does, it will arrive with a tune that statistics cannot hum. Until then, the discipline is to ask questions shaped like null tests. Does the arrival rate match predictions from models of ejection and detection? Do arrival directions cluster in ways that mirror stellar streams rather than cultural calendars? Do light curves contain algorithmic structure that resists compression far beyond what outgassing can produce? Einstein once framed gravity as geometry that tells matter how to move, and matter that tells geometry how to curve. Inside that framing, calling is a metaphor for curvature reaching out to motion. The metaphor is beautiful and safe. It keeps poetry where it belongs, as a companion that rides in the carriage while mathematics holds the reins. Hawking taught the world to see randomness with reverence, to recognize that noise can carry the signature of deep order when seen at the proper scale. Between those teachings lies a posture. It is the posture of listening without superstition, of measuring without cynicism, of letting ideas audition without granting them the stage before they sing. Ultimately, the question of intent becomes a mirror. It reflects the habits of the observer more than the habits of the observed. Minds trained by scarcity find patterns in thin data. Minds trained by abundance demand patterns to justify faith. In the open air between those schools, a traveller crosses a star's domain under no compulsion except energy and initial conditions. The appearance of invitation rides alongside as a human colour on a physical canvas. The colour is not a crime. It is a reminder that curiosity contains longing. Longing is not evidence, yet it is faithful fuel. So the inquiry continues, not to banish the word called, but to translate it into terms that instruments can test. If the translation fails, patience grows stronger. If a translation someday succeeds, humility will be essential, because the discovery will have arrived through a discipline that refused to bend early. Either outcome dignifies the night. Either outcome leaves the sky vast and intimate at once, a place where motion writes meaning only when minds put the letters together with care. The galaxy can be read as a braided river, spread across a plain of stars. Its currents are not water but gravity and motion. Debris from worlds that once circled distant suns drifts along those currents, turning gently where tides lean and flowing straight where space relaxes. Luminous harbours punctuate the bank. Each harbour is a star whose mass carves a basin into space-time. A passerby that enters the basin does not need invitation. It only needs to exist, to carry momentum, and to surrender a fraction of direction to the local pull. In that quiet choreography, wandering stones learn to visit light. Birth sets the debris afloat. Around young stars, disks of gas and dust ferment into planets, and the leftovers scatter. Some fragments are pushed outward by giants migrating through resonances. Some are flicked by close encounters with growing worlds. A fraction clears the boundary of the home star and joins the general traffic of the galaxy. Their motions preserve the speed and direction of the parent system, folded into the wider swirl of orbits around the galactic center. The result is not a fog, but a current that remembers where it began. Spiral structure shapes the next part of the journey. The arms are not solid bridges of stars. They are regions where gravity slows rotation just enough to gather matter, like eddies in a river. As systems enter and leave these regions, their speeds shift by small amounts and their paths bend. Molecular clouds inside the arms act like submerged boulders. Passing near one changes a fragment's course by a few slow degrees, enough to alter future encounters by light years. Over time, these low-grade deflections sculpt streams in phase space. The galaxy gains a texture that a patient census would reveal as filaments rather than fog. The galactic tide does its own work. The combined pull of the disk and the bulge creates a gentle gradient that rises above and below the plane. Orbits bob. A small body far from any star feels a vertical acceleration that lifts it out of the mid-plane and later slides it back. Radially, there is a weaker tug toward and away from the center. Together, these components trace epicycles on top of the broad rotation around the core. A fragment thrown outward billions of years ago will have ridden many such loops. Each loop changes where that fragment crosses the star-filled plane, and each crossing passes closer to some stars than to others. The intersections create opportunities for encounters without any hand on the tiller. Stellar streams and moving groups add a sharper pattern. When a cluster dissolves, its stars stretch into a ribbon that can wrap partway around the galaxy. Any debris ejected from their planets inherits that ribbon. If another star crosses the ribbon, the local density of wanderers rises for a while. The effect is subtle and long-lived. It is the reason that encounters with interstellar bodies can arrive in flurries, separated by quiet years. A patient observer might eventually see preferred directions of approach that map onto the known stellar streams, as if they were signposts written by dynamics. Individual stars are lenses on a smaller scale. A solitary mass focuses nearby trajectories the way a glass bends rays of light. Far from the star, debris flows in nearly straight lines. Near the star, the lines curl inward by calculable amounts. The enhancement in the number of passers is strongest for bodies that arrive with modest speeds relative to the star. The same role belongs to every sun, not because it decides, but because curvature is impartial. A bright harbour therefore amplifies a small part of the river without changing its overall tide. Planets inside a stellar basin complicate the picture by opening doors that are narrow and rare. Where a giant like Jupiter moves, the combined gravity of star and planet creates valleys and passes in the energy landscape. Some passes lead to temporary capture, a brief stay that might last weeks or months before exit. Others form tubes through which a traveller can thread the system with minimal expenditure of energy. These structures are called weak stability boundaries in the language of celestial mechanics. They are like quiet backwaters where driftwood can circle before slipping back into the stream. Such captures barely occur, but their existence reminds that rivers have eddies as well as channels. The medium between stars is not empty. It is a thin plasma laced with magnetic fields and salted with neutral atoms and dust. Stars blow winds into that medium. Each wind inflates a bubble called an astrosphere that balances outward pressure with the inward pressure of interstellar gas. The boundary is a contact surface with a bow shock or a bow wave ahead of it, depending on how fast the star ploughs through its surroundings. Large interstellar bodies are immune to this gentle weather, but grains and pebbles are not. They are filtered, charged, and deflected by fields and shocks, altered in number and direction before they can approach deep within a system. The very smallest dust grains are tied to magnetic lines like seeds to currents. The largest boulders ignore the wind altogether. In between, a band of sizes experiences a nudge that a careful model can predict. Radiation from stars supplies another wind of a different kind. Photons push on surfaces. For objects the size of mountains, the push is negligible. For small grains, it is a sail. Pointing Robertson drag steals a whisper of angular momentum from dust that already circles a star. For true drifters arriving from outside, radiation pressure can widen tails of tiny particles that lift from a warming surface. The altered area to mass ratio of those particles makes them more sensitive to the star's light than the nucleus that shed them. A halo of dust can therefore be redistributed into shapes that trace pressure as much as gravity, a visible signature of winds that are made of light. Numerical experiments help the eye see what equations alone can hide. Integrations of millions of test particles in smooth galactic potentials reveal that the river is not uniform. Filaments form, voids appear. Resonances with the bar at the center and with spiral patterns create lanes of preferred motion. Tilt the starting conditions and the lanes change. Introduce molecular clouds as moving perturbers, and the filaments fray into braids. Into this woven flow, every star inserts its small lens. The result is a layered structure of currents upon currents. A traveller that enters one layer inherits deflections from the ones nested above it, just as a leaf might surf a riffle that rides a larger surge. Timescales stretch beyond intuition. 100 million years is a short lap around the galaxy for a body that lies near the sun's radius. 1 billion years is a patient afternoon. Across such spans, the chance that any particular star will be threaded by many drifters approaches certainty. The question is not if, but when, and from which corridor. Place an instrument at a fixed window, and the river will eventually send a procession. A coincidence of arrival and attention can feel personal only if the length of the river is ignored. The local neighbourhood contributes one last influence. The sun currently bathes inside a cavity of hot, thin gas bounded by denser shells. Nearby lies a gentler cloud through which the system moves at dozens of kilometers per second. That motion sets the direction from which neutral atoms and dust enter the heliosphere. It sets the tone for the wind against which the solar breeze pushes. As the sun drifts into regions of slightly different density and field orientation, the character of that inflow changes. Small bodies feel the change. Large ones do not, except through how sunlight and solar gravity sculpt their wakes of dust. A census taken across centuries would see modulation, a slow breathing over human history that rides on the star's own path. All these influences add rather than compete. Ejection writes the first line of a fragment's biography. Spiral structure, clouds, and tides write the long middle. Stars and planets write the brief encounter near a harbour. Winds and light annotate the margins with whispers and flourishes. To a mind watching from a single world, these layers can look like intention. To the larger view, they are the grammar of a river that needs no author. The grandeur lies not in any single mechanism, but in their harmony. A stone can be born in a distant cradle, drift through a braided galaxy for eons, and arrive within view of a telescope simply because the river flows and the harbours shine. The star at the centre of the system is more than a furnace. It is a lens. Curvature gathers near its mass the way ripples gather near a stone in a stream, and paths that would have stayed indifferent bend by small, exact amounts. Nothing in this lens speaks in a human voice. Nothing chooses, yet the bending thickens traffic along certain lanes, and a passerby that might have missed the inner country by millions of kilometres slides inward instead. The effect is quiet. It is the reason a sky can seem visited without any summons at all. Light reveals the principle with elegant simplicity. A ray that just grazes the bright limb of the star deflects by a hair-breadth angle, a note written once by theory and later measured in the faithful units of arcseconds. Parallel rays do not converge to a point. They converge into a long focal line that begins far beyond the planets, a place where the star's geometry turns distant starlight into a bright ring around the sun's silhouette. The first usable point on that line lies hundreds of astronomical units from the furnace, beyond the slow orbits of frozen worlds, beyond the whispering pressure of the solar wind where sunlight is thin as thought. There the lens does not form images in the ordinary way. It builds a narrow cylinder of gain that stretches like a quiet corridor through space. Matter answers to the same curvature in a different register. A traveller that carries its own inertia rather than the speed of light feels a larger deflection for the same grazing distance. The slower its arrival, the more it bends. As it approaches the inner system, the star's pull increases the local density of possible paths. A simple relation captures the effect for bodies moving too fast to be bound. The flux of passers at a given distance gains a factor 1 plus the local escape speed squared divided by the square of the incoming speed at infinity. At the orbit of Earth, the escape speed from the star is a little above 40 kilometers per second. If an interstellar fragment arrives at 30 kilometers per second, the enhancement is nearly a factor of 3. If it arrives at 50, the enhancement is smaller but still real. The star does not beckon in any intentional sense. It widens the corridor by which wanderers can draw near. Geometry gives the lens its grace. Imagine a sheet of trajectories falling toward the star from far away, all parallel and sparse as winter rain. Each path can be labelled by an impact parameter, the closest approach it would have if the star's pull were absent. With gravity present, the sheet crumples. Paths with small impact parameters bend most. Paths with moderate ones bend a little. Far from the star, the sheet smooths out again, but not before becoming denser near the axis. That temporary crowding is the signature of focusing. An observer in the inner system sits inside those caustic folds from time to time, and for a while the probability of witnessing a crossing grows. The lens for light and the lens for stones interfere with nothing. They coexist. The photonic lens demands a distant alignment of background and star and observer. When that alignment occurs, the halo of magnified light appears as a ring nested around darkness. The material lens asks only for a river of debris with some distribution of speeds and directions. Where the star moves relative to that river, the inflow tilts. A thin cone of enhanced density forms downstream, aligned with the motion through the local medium. For neutral atoms and specks of dust, that cone can be mapped directly. For larger bodies, it hides inside probabilities that only bloom during long surveys and careful patient counts. Planets add structure to the focusing. Their masses carve smaller lenses inside the larger one, each with its own sphere of influence. A traveller that runs the gauntlet near a giant world may leave along a very different heading than a traveller that stayed in the star's field alone. There are tubes in this combined field where motion is barely bound for a while, places where a passer can idle before slipping away. These are the weak stability boundaries of celestial mechanics, narrow as threads and difficult to enter. They are reminders that the lens has fine structure. In that lacework, close calls and temporary companions can occur without violating the larger verdict of freedom. Radiation does not break the lens. It changes what is seen within it. Photons push on small pieces, and the push increases when the grain is tiny and bright. Gas jets that wake on a warming surface can aim forces that spin a body and shift its path slightly, altering the direction of dust rather than the course of mass. Thus, a coma may trace lines that are set partly by sunlight rather than purely by gravity. The nucleus still obeys the curve that energy demands. The haze around it becomes a visible manuscript of secondary winds. The lens also sets a clock for encounters. Bodies that enter at shallow angles and modest speeds experience greater bending, which lowers their perihelia and shortens the period of their passage through the bright inner zone. Bodies that skim the outer rim of the field spend longer near the level where telescopes do their best work, but their focusing is less generous. Observers who plan must decide if they chase a faint, slow arc at a distance or a brighter, brief flare that dives deeper. The lens supplies both options. The sky decides which arrives next. Einstein's insight frames the philosophy of this lens. Mass teaches space to curve, and curved space teaches paths to bend. In that mutual instruction, a star becomes a quiet artist that draws probability toward itself without intent. Hawking's lessons about entropy add a parallel thought. Order that appears locally can arise from lawful statistics that are indifferent to human meaning. A season with more crosses is not a story about preference. It is a paragraph in the long book of dynamics, written by the shape of the potential well and the distribution of incoming speeds. The focal line for light invites one harder thought. If the corridor were occupied by an instrument, a distant world could be imaged through the star's magnifying field with a sharpness beyond ordinary telescopes. That same alignment, viewed from here, would draw a ring in the sky. Natural rings are common when galaxies lens one another. Around a single star, they are rare to the point of delicacy, and they usually require vantage points far from home. The idea remains a reminder that the lens is not metaphor. It is a practical machine, operating whether or not a witness stands in the one place where its power peaks. In the language of particles, the lens turns the star into a governor of encounter rates. The enhancement factor depends on speed at infinity. A population of slow drifters contributes many near misses and a few deep passes. A population of fast drifters crosses with little deflection and is seen if and only if the initial trajectory already favoured the inner system. Over many years, a catalogue of paths will reveal the mix. It will show whether the river that feeds the star is dominated by quick shards from violent ejections or by slower pebbles from gentler slings. The star does not keep a guest book. Surveys become the book, and the curve of focusing becomes the ink. Even without catalogues, imagination can visualize the quiet beacon the star becomes. Not a lighthouse that flashes commands, not a siren that sings, a steady gradient that says only this. Here the energy is lower. Here paths bend inward a little. Here line density thickens, and a traveller that might have stayed unseen will cross a field of view coloured by sunlight. The beauty of that message is that it is universal. Every star speaks it. Every traveller hears it. From that universality comes a sense of belonging that does not require story. The lens is enough. In the deep night beyond metaphor, a single object approaches. It carries its own biography in its motion and its mix of ice and rock. The star shapes the next paragraph of that biography by bending the line through a calculable angle. No voice calls, no answer is required, yet the bending has a way of arranging meetings. An encounter that would have been impossible becomes barely possible. Barely possible becomes likely. Likely becomes measured. The lens has done its work. Space remains curved, and in that curvature the quiet seems almost like invitation. Imagine a body that looks like rock, yet breathes like ice. The surface is a muted armour of dust and polymer dark, a skin soldered by sunlight, micrometeor strikes, and long radiation. Beneath that skin, cold persists in layered pockets where ices sleep. In those pockets, carbon dioxide waits closer to the light than water does. The arrangement is not accidental. It is the outcome of heat that never lingers, of pores that favour some molecules over others, and of a crust that both protects and misleads. Every orbitless wanderer that enters starlight carries a small weather. At sunrise on the nucleus, the upper millimetres warm in minutes. Heat sinks a short distance, then stalls against a poorly conducting interior. The depth that senses day and night is measured in centimetres when rotation is quick and the material is fluffy. The seasonal wave reaches deeper, but not far, and it arrives late. Such a shallow fever creates layers. Just below the daily skin, frosts of carbon dioxide feel enough heat to stir. Deeper down, water ice remains in the shade of conductivity. In this regime, the first molecules to rise are not water. They are the ones whose bonds to grain surfaces surrender at lower temperatures. Crust grows from this schedule. When ices wake, they tug at grains lodged in pores. Small fragments are easy to lift at first. Over time, the finest grains are winnowed away, leaving a lag of coarse material that resists flight. Solar heating rounds edges and sinters contacts until adjacent particles weld into plates. Electrostatic forces add a final glaze by attracting dust that rises and falls in weak fountains at the terminator. The result is not a monolithic rock. It is a composite cap with porosity threaded by tortuous passages and sealed by occasional crusts of organic varnish. Its strength is measured in handfuls of pascals to kilopascals, barely enough to stand as a roof, but enough to turn free outflow into a slow exhalation. Gas moving through such passages does not flow like wind through pipes. In the low-pressure regime, molecules ricochet from wall to wall more often than they collide with one another. Transport becomes a ballet of random steps called Knudsen diffusion. The rate depends on pore size, temperature, and the molecule's own mass and sticking behavior. Carbon dioxide, less tightly held than water at the same temperature, finds the maze more forgiving. It percolates, collects in cavities, then slips upward through the easiest throats. Water, more adhesive and colder at equal depth, lingers and refreezes inside the labyrinth. Spectra above the surface, therefore, proclaim a composition that does not mirror the bulk. The skin edits the voice of the heart. There is a second editor buried in the ice itself. Amorphous water, when warmed past a critical threshold, reorganizes into a crystalline lattice, and in the act releases trapped volatiles. If the deep, cold, preserved gases in those amorphous cages, modest heating can liberate carbon-bearing molecules before the water matrix sublimates in earnest. The liberation is sporadic and local, because temperature waves do not penetrate evenly. Where a fracture delivers warmth faster, a patch may light up while a neighboring patch remains quiet. The coma above records the patchwork in fans and asymmetries that change with hour and angle of sunlight. Pressure builds behind every choke point. When the gas in a pocket cannot escape as quickly as it is produced, the roof lifts in slow elastic flexing until brittle strength fails. Then a crack races through the cap, a microquarry opens, and a jet begins. The material ejected is not a spray of boulders. It is a filament of gas bearing dust no larger than the passages could deliver. Such jets start and stop with the rotation of the active region into and out of sun, but they also stutter from deeper cycles as cavities empty and refill. To a remote eye, the pattern can mimic a change in bulk production, when it is really the choreography of a few throats. Shape matters in this story because light does not graze every point equally. Depressions hold shadows like cups. Rims bask. The boundary between the two is a mobile front where thermal stress concentrates. The stress runs along ancestral fractures seeded by impacts and past outbursts. When the stress exceeds the reduced strength of radiation-processed organics, seams widen by hairbreadths. Those seams are the preferential paths for gas, and their orientations fix the lean of jets and the skew of the coma. A slight tumble of the body can rearrange this geometry in hours, steering the same engines into different skies without altering the underlying chemistry at all. Permeability evolves as the crust ages. Fresh lag is leaky. Repeated heating and cooling shrinks pores, collapses bridges, and deposits resublimed frost inside channels. Think of a snowbank that has turned to wind-hardened crust where footsteps no longer sink. In microcosm, the same transformation throttles flow. Early in a passage, the spectrum is loud in volatiles, with lower binding energies. Later, the same surface grows quiet unless a fracture tears it open. When such an opening occurs, the escape of deeper ices can mimic a sudden chemical change. In truth, the inventory has not transformed, only the door has. Dust tells its own version of this tale. If grains are bound by thin films of refractory organics, they require more force to lift than the gas near the surface can provide. A coma then appears, gas-rich and dust-poor, bright in specific bands but demure in reflected sunlight. Where vents focus streamlines, some grains do escape, and polarimetric measurements would sense compact particles rather than fragile aggregates. Downrange, As grains fragment under thermal stress or collide, the polarization curve evolves. Such evolution, if mapped against rotation and aspect, could trace the architecture of venting and the places where the crust is weakest. There is also a role for clathrates, those cages in which water encases guest molecules at pressures that can exist under an insulating blanket. If such structures formed in the parent disk and survived the long cruise, their breakdown temperatures create a second ladder of release. Carbon dioxide emitted as a guest can depart at lower temperatures than the host would normally permit for its own sublimation. The crust then needs only to hold until clathrate breakdown delivers a burst. The timing of these bursts depends on depth and on the thermal inertia of local layers. A patient sequence of measurements could distinguish clathrate-driven episodes from ordinary sublimation by the shape of the rises and the flavors of the gases that lead them. In this architecture, water is not absent, it is quiet. To unmask it, heat must penetrate further, or cracks must widen enough to bypass the maze. That transition often aligns with the weeks when a star stands highest in the sky of the nucleus. The phase angle of illumination matters, so does the cadence of rotation. A long noon on an active longitude can drive heat past the skin depth into the shelf where water waits. When that shelf engages, the coma changes voice, adding the familiar signatures that dominate in comets born near our own frost lines. Before that engagement, carbon dioxide plays solo, and the ear is tempted to misjudge the orchestra by the leader. Predictions emerge naturally from this micrometeorology. If the crust rules, gas production should respond more to stress and crack growth than to smooth increases in insulation. Activity would rely on a small number of vents with stable positions but variable throughput. The column density of carbon dioxide should carry periodicities keyed to rotation, with harmonics introduced by the switching of jets on the far side of the body that scatter light into view. Dust features should lag gas features by minutes as grains accelerate. Thermal emission from the nucleus should show hotspots narrower than the beam of a typical infrared instrument, betraying the presence of vents rather than uniform heating. There is a tenderness in this model of resistance and release. The stone-like skin protects the ancient cargo beneath, keeping the core so cold that it remembers how to be young. What reaches the void is the fraction that learns to thread a crooked path, small molecules slipping through gates that larger ones can barely fit. The paradox is that a hard face can make a body seem chemically alien when it is only acoustically filtered. Once a seam tears wide and the deeper breath begins, the song will change again. The phrase "skin of stone" and "heart of frost" is not poetry alone. It is a physical compromise written by low conductivity, weak gravity, and a slow bake. It takes little to thicken such a skin and little to break it. A pebble thrown by a spall, the flecks of tides near a planetary pass, or the cumulative pry of gas along an old fault can rearrange the entire script of emission in an hour. The lesson is not to trust the first lines. The lesson is to listen for the muffled choir under the soloist, and to understand that a quiet heart can sing loudly once the theatre doors open. The cloud around the traveller is not fog, it is script. Every molecule that leaves the surface learns to speak in light when the star's photons strike it, and each syllable lands at a precise wavelength the way a note lands on a staff. A slit opened on that haze turns the scene into grammar. The crisp violet of cyanide, the jade of forbidden oxygen, the pale gold of sodium, the quieter embers of nickel and iron, all of them together become a paragraph about birth and weather written in fluorescence. Cyanide is the extrovert. The violet band near 388 nanometers responds eagerly to sunlight, its upper states pumped by solar ultraviolet like lanterns catching a match. The line set is strong even when the coma is thin. Measuring it with a narrow filter or with high-resolution Echelle spectra returns a production rate that often stands in for its parent, hydrogen cyanide, which breaks apart rapidly after leaving the skin. A classical column density model, simple and honest, translates intensity into molecules per second by assuming steady outflow and a photochemical lifetime under the sunday. The physics is modestly idealized, but the map it yields is serviceable. It shows a cyanide field that blooms off the sunlit limb and stretches in a faint streamer antisolar, a sign that radiation pressure and outflow speed are co-authoring the page. Hydroxyl lives where the air is harder to read. The band near 308 nanometers is the child of water, a prompt product of photodissociation. It lurks in the ultraviolet, where ground-based eyes struggle through ozone. Yet, with spaceborne eyes or careful corrections, the signal emerges. When it does, the line tells of water's voice without the water itself needing to vaporize loudly. A faint hydroxyl field alongside a robust cyanide field implies that the deeper reservoirs still hold their breath. An increase later would reveal the opposite, a delayed opening of gates that allow water to write its name across the coma. Carbon chains carry their own handwriting. Dicarbon builds the green slashes of the swan bands near 516 nanometers. Tricarbon leaves a smoky signature near 405. These families usually bloom where sunlight has time to cook their parents into children and then into grandchildren. If they appear early and strongly, the ancestry leans toward richer organics in the surface mix, or toward a residence time in sunlit gas, long enough for chemistry to proceed. If they are subdued, the coma is either young, thin, or edited by a skin that lets simple molecules escape while trapping complex ones in the pores. Oxygen writes in the language of auroras. Forbidden lines at 557.7 and at 630.0 and 636.4 nanometers arise when the atom is left in a long-lived, excited state after a water or carbon dioxide molecule is torn apart. These lines are delicate because collisions at high density can quench the excited atom before it radiates. Their very presence therefore reports on the thinness of the coma and on which parents are being sacrificed to sunlight. A relatively strong green line, compared to the red pair, suggests a larger contribution from carbon dioxide, while red dominance whispers that water is doing more of the work. The ratios change with distance from the nucleus as densities fall and quenching relaxes, a natural gradient that turns the coma into a laboratory for low-pressure kinetics. Sodium is erratic but revealing. The doublet near 589 nanometers often appears as a narrow ray, sometimes extending far beyond the main envelope. Sodium is freed when tiny grains are heated, cracked, or sputtered by light, and the atom responds to the star with a fluorescence that is bright for its abundance. A thin, well-collimated sodium tail, aligned near the antisolar line, points to dust as the source and to radiation pressure as the sculptor. If sodium is weak, the dust is either coarse and reluctant to release atoms, or buried in gas, where line-of-sight geometry hides the plume. Ions bring electric geometry into the picture. Bands of carbon monoxide ion near 426 nanometers and of molecular nitrogen ion near 391 brighten in a tail that curls with the wind of the star. Their presence signals not only abundant parent molecules but also the speed and direction of the local plasma. Mapping their intensity along and across the tail sketches an invisible magnetic field that the neutral coma would never betray. If the ions are meager, while the neutrals are loud, the local wind may be slow or the photoionization pathway suppressed by shading within the coma. Metals speak in a whisper that has become a little louder in recent years. Neutral nickel and neutral iron lines pepper the optical spectrum, faint but real, even at distances where ordinary sublimation seems slow. Their origin is a subtle puzzle. Thermal desorption of metal-bearing organics, photolysis of complex grains, and micro-impacts that shock the skin into exhaling are all capable of producing a thin population of free atoms. The detection of those lines has a quiet power. It asks whether metals are present as simple salts, as inclusions in rock, or as guests in ice cages that release them when the lattice relaxes. Each possibility points to a different history of grain growth in the cradle where this body formed. Infrared light carries the voices that visible light cannot host. Carbon dioxide speaks strongly at 4.26 micrometers and at 15, water at 2.7 and 6, carbon monoxide at 4.67. In this regime, sunlight pumps molecules that then re-radiate by vibration rather than by rotation alone. The line shapes are wide enough to betray temperature, and sometimes narrow enough to betray outflow speed when instruments resolve them finely. A warm band from carbon dioxide alongside a cool hush from water turns the earlier inferences into muscle. Dust thermal emission rises nearby, as a continuum with a color temperature that reports the balance of grain size, composition, and distance from the glow. Submillimeter and radio lines become the last lines of the alphabet. They are the domain of rotation, where molecules turn like clock hands and emit at frequencies that millimeter dishes taste with exquisite appetite. Hydrogen cyanide, methanol, formaldehyde, and other small species fill this ledger with transitions that can be modeled to obtain column densities, temperatures, and sometimes the spatial distribution of emission. An interferometric map turns the coma into weather, exposing jets as crescents and sheets, showing whether carbon-bearing gases and water share sources or prefer different latitudes on the nucleus. Turning these many alphabets into fluent speech requires models that are honest about the wind of gas leaving the surface. The classic approach imagines a steady, spherically symmetric outflow with a fixed speed, parents that decay into daughters, and lifetimes set by the sun's brightness at the current distance. That hazer frame is durable because it is transparent, yet comae are not spheres, and outflows are not steady. Modern tools add vectorial corrections for the momentum of fragments, photochemistry that respects angles of sunlight, and Monte Carlo walkers that learn the maze of collisions and quenching near the nucleus before streaming freely outward. When such models are fit to imagery and spectra together, the alphabet gains syllables. Polarization of scattered light adds a quiet diacritic to the vowels and consonants. The degree of polarization as a function of phase angle and wavelength betrays the grain size distribution and the texture of the dust. Compact, processed grains polarize differently than fluffy aggregates. Organics darkened by radiation change the slope of polarization with wavelength. A coma whose polarization curve lies offset from the common envelope for familiar comets implies a recipe for dust that did not cook in this star's kitchen. The helicity of all these signs is time. Repeat an observation after one rotation of the nucleus and the map changes. Repeat after two and patterns emerge. Jets flicker in and out. Ratios breathe with the angle of sunlight. A flare in carbon monoxide in the pre-dawn hour of the body's day suggests a subsurface pocket opening to an old crack. A slow strengthening of oxygen's red line over weeks marks the broader engagement of water ice as seasons shift. The coma is a living archive in the least sentimental sense, updated in real time by physics that knows no audience. Patience turns alphabet into meaning. Cyanide says something about organics near the surface. Hydroxyl says something about water deeper in. Oxygen's forbidden glow says something about which parents are being torn apart and where. Sodium says something about dust that cannot stay whole. Ions say something about the wind that combs the coma's hair. Metals say something about the cradle's chemistry and the long polish of interstellar travel. Infrared bands say something about temperature and layering. Polarization says something about texture. Together, they sketch a portrait that betrays no intent and hides no wonder. The signals in the coma are less a message than a patient census of what is possible for a small world that learned to speak when a star warmed its face. A memory haunts the sky, a sliver that crossed a decade with the poise of a riddle. It carried a name shaped by a language of welcome, and for a few brief weeks, it turned a survey's routine into a meditation. Its orbit said interstellar with no hesitation, yet its body refused the costumes that make comets obvious. Telescopes searched for a veil of gas and found only silence. Photometry, however, would not be quiet. The light rose and fell by several magnitudes in a cadence that hinted at a shape either fantastically stretched or startlingly flattened, and at a spin that did not respect a single axis. The numbers could be made to fit a cigar or a disc, depending on assumptions about surface brightness and viewing angle. Both pictures were honest. Neither could claim certainty. The absence of a clear coma became the first instruction. Sublimation can be delicate, and gas that leaves in whispers can carry dust grains too fine or too few to brighten images. A mantle baked by cosmic rays can seal pores until heat seeps just far enough to open a lattice from within. The coma then becomes a ghost rather than a banner, detectable only in spectral lines fainter than hurried surveys can gather. That lesson did not prove that every interstellar shard would be shy. It proved that shyness is compatible with freedom, and that outgassing need not announce itself with a tail. Non-gravitational acceleration offered the second instruction. The track through the gravitational field showed a residue that did not belong to the pulls of star and planets alone. The extra push was tiny, sustained, and aimed roughly away from sunlight. The simplest teller of such tales is venting, but vents usually reveal their parents in spectra. When spectra refused, another teller stepped forward. Radiation pressure can push if area per mass is high, if the body is light and broad, or if lifted dust grains shift the observed center of light just enough to mimic a nudge. Each possibility demanded properties that strained comfort without quite breaking it. The moral was modest. Models must allow forces that are not immediately visible. Tumbling became the third instruction. A body that rotates around two axes at once will not offer a single crisp period. Its highlights shift as facets present and withdraw, and thermal stress races along seams in patterns that change as illumination walks across planes rather than spinning evenly around a pole. In such a state, heat penetrates unevenly and outgassing, if present, arrives in bursts that repeat, skip, or drift. Coma structure becomes choreography rather than clockwork. Light curves that seem to promise simple geometry are therefore traitors. They whisper of a dance under the costume of a metronome. Color and reflectance added nuance rather than answers. The spectrum reddened with wavelength in a manner familiar from surfaces seasoned by radiation, a tone common to many outer system bodies. Albedo estimates, chained to size through assumptions about thermal emission that were themselves uncertain, wandered across a range wide enough to keep artists and dynamicists equally unsatisfied. A small, dark shard could imitate a larger, warmer plate. Data from infrared eyes helped, but did not close the case. The lesson here was humility. Shape, size, and surface are a triangle that observations resolve only with patience and luck. Hypotheses multiplied with the discipline of a laboratory and the appetite of a myth. Hydrogen ice carved from a giant molecular cloud could have sublimated invisibly, leaving little to betray itself except a sustained push. Nitrogen ice chipped from an exo, Pluto could have carried the right volatility and the right reflectance to explain both the acceleration and the color. A fractal aggregate of dust, porous beyond intuition, might have presented an enormous sail to sunlight while remaining featherlight. Water ice beneath an organic crust could have exhaled through pores too fine to lift dust, producing thrust without visible spray. None of these possibilities wore a crown. Each made predictions that skirted the edge of detectability. The enduring lesson was not which one was right. It was that the space of plausible physics is broad when measurements are few and distant. Dynamics offered a quieter teaching. Interstellar fragments will arrive with speeds and directions drawn from the churn of stellar neighborhoods, not from a single stream. Some will thread the inner system along shallow angles, some will cut deep, and some will miss by distances too large to mourn. The first memorable visitor did not align with any famous stellar flow in a way that could convict a birthplace. That modesty reframed expectations. A single trajectory, however poetic, seldom points home across light years. Only a population will sketch the map. Interpretation learned to distrust inference by silhouette. A large amplitude in brightness can be carved by shape, albedo pattern, or both. A pancake with a mottled surface can sing the same photometric song as a needle with uniform paint. Without radar or a resolved image, the two tunes blend. Analysts built priors, tested them against thermal limits, and reminded one another that extraordinary shapes are not required when ordinary shapes wear patchy coats. The instruction here sharpened methodology. It counseled against gambling on singular geometry when nature loves mixtures. The episode also trained attention on outgassing at low levels. Laboratory experiments and models of rough, low conductivity surfaces showed that small fluxes can live under detection thresholds while still producing measurable forces over weeks. The flux need not be water-dominated. Trapped gases released during phase changes or by the breaking of clathrate cages can supply momentum without substantial dust. The third piece of instruction clicked into place. Chemistry at the interface between ice and vacuum is a storyteller with many dialects, and an instrument that hears only one dialect will find the narrative thin. A cultural note shadowed the physics. The public appetite for purpose found in a silent shard, a canvas large enough for folklore, yet the scientific reply remained steady. Prior probabilities for agency are low, and unexplained is not a synonym for deliberate. The lesson was not to ban wonder, but to separate the fuel of curiosity from the oxygen of evidence. That separation preserved the integrity of the search while keeping the door open to surprise should a future traveller write in clearer lines. The instrumentation landscape learned to adapt. Survey pipelines widened their priors for acceptable motion and brightness behavior. Follow-up programs built faster ladders to reach near infrared bands where volatile signatures reside. Polarimetry returned to the foreground as a way to read dust texture when dust is faint. Coordinated cadence across longitudes gained honor as a method to beat tumbling with coverage. The episode's practical inheritance was a set of small improvements that together make the next surprise less opaque. Even the void between firm answers found meaning. A shard that left without telling its whole story taught how to listen better to the next. It reminded that patience is not passive, that it is a discipline of preparation. The shadows it cast lay not only on models of composition and shape, but on habits of thought. Confidence learned new boundaries. Skepticism learned gentleness. A final instruction came from scale. An object a few hundred meters across can trigger global conversation, consume telescope time across continents, and still refuse to reveal the key apertures of its heart. That ratio between attention and size says something intimate about humanity. It says that small things can widen the sky when they are old enough and odd enough. It also says that the universe is under no obligation to fit inside the categories that taste familiar. In the end, a handful of truths stayed sturdy. Hyperbolic motion can belong to bodies that look more like asteroids than comets, even as they feel small pushes from sunlight or hidden gas. Light curves can imitate many shapes. Subtle chemistry can hide beneath detection while sculpting a path. Photons can shove more than pride, allows if the sail is broad or the mass is slight. And explanations that seem exotic can grow ordinary as instruments sharpen. These truths do not solve new mysteries in advance, but they calibrate expectations and quiet the impulse to declare conclusions while data are still thin. The shadow that remains is not a darkness. It is relief, the kind an engraver cuts to reveal depth in a plate of copper. In that relief, future travelers will stand out more clearly. Their spectra will be read with fewer assumptions. Their light curves will be folded with more care. Their small pushes will be weighed with a scale built from experience rather than haste. One shard left, and the sky kept its posture. The instruction was simple and generous. Look harder, speak softer, plan for strangeness, and let the data lead. Consider a small world assembled in a narrow ring of cold, where carbon dioxide first begins to freeze. In a young disk, temperature falls with radius, and each volatile finds a frontier beyond which it condenses onto grains. Water claims the inner frontier, carbon dioxide the next, carbon monoxide farther out, nitrogen farther still. At the carbon dioxide frontier, the gas of the disk meets a regime where oxygen is generous and ultraviolet light threads the upper layers just enough to drive chemistry on dust. There, carbon monoxide on grain surfaces meets oxidized radicals and turns into carbon dioxide. Frosts bloom on pebbles that drift through the midplane like pollen through air. The materials at that radius become a recipe with a new proportion. Water present, but not dominant in the layers nearest the light. Carbon dioxide abundant and ready to bind the aggregate. Pebble accretion works efficiently in such a band. Millimeter grains collide and stick into centimeter clumps, then into decimeter bodies, growing fast enough to outrun the tendency to drift inward and evaporate. The matrix they build is porous, a foam of ice and dust baffles. In that foam, carbon dioxide coats surfaces and fills pockets, while water ice nests deeper in the colder interior and occupies clathrate cages where conditions permit. Photochemistry paints organics onto exposed grains, darkening the mix into a protective varnish. The young object becomes a layered archive. Near the exterior, carbon dioxide sits close to the day side that any future star will warm. Beneath, water and more refractory ices wait in reserve like a deeper season. The thermal environment at the carbon dioxide frontier imprints a second signature. Temperatures hover where carbon dioxide is stable, water too, yet the balance of sublimation energies favors carbon dioxide release under modest heating. Low thermal conductivity preserves stratification. Sunlight that someday crosses the surface will heat the upper centimeters quickly, then stall. The first molecules that learn to exit will be those whose bonds to grains surrender at the shallowest depth. Carbon dioxide begins to move. Water remains quiet. Outgassing, therefore, carries a bias independent of overall composition. A skin of dust and irradiated organics strengthens this effect by editing the escape routes, allowing the smaller, more weakly bound carbon dioxide to insinuate through pores that water finds unfriendly at the same temperature. Porosity and sintering collaborate to protect this architecture across aeons. In the interstellar cold, microcontacts grow where grains touch, slowly welding bridges that make the foam resilient without sealing it. Cosmic rays process the outer microns into complex organics that absorb sunlight and promote a thin, insulating crust. The crust is not a solid sheet. It is a leaky roof with winding capillaries and occasional weak seams. Behind that roof, carbon dioxide pressures can build at dawn on the nucleus, flexing the cover until a crack opens. The gas then escapes through a small throat and writes a narrow fan into the coma. Water follows only when heat sinks deeper, or when clathrate breakdown liberates guests from cages at temperatures below water's ordinary sublimation threshold. If a growing giant planet migrates near the carbon dioxide frontier, scattering begins. Some small bodies are tossed inward to evaporate and feed the inner disk. A fraction are thrown outward or upward, and a few cross the limit of escape entirely. Those few become citizens of the galaxy. Their surfaces, already varnished and strengthened by gentle sintering, survive long exposure to radiation and micrometeor strikes better than fluffier aggregates from softer kitchens. When such a survivor enters a new star's light, it presents a face conditioned to vent carbon dioxide readily while keeping water in reserve until a later phase of heating. The dynamics of its present orbit do not reveal its cradle, but the chemistry of its first breath does. The hypothesis of a primitive carbon dioxide worldlet makes predictions that can be weighed. The strongest lines in early spectra should cluster near 4.26 micrometers and 15 micrometers, signatures of carbon dioxide vibration. Oxygen's forbidden green line should compete with or exceed the red pair close to the nucleus, where quenching is still mild, reflecting a larger role for carbon dioxide photodissociation. Hydroxyl at 308 nanometers should rise later or more weakly than a comet rich in shallow water would suggest. Carbon monoxide may not dominate, because the annulus where carbon monoxide is stable lies farther out, and conversion on grains near the carbon dioxide frontier can lock carbon into the dioxide form. Methanol could appear in modest strength if hydrogenation pathways remained active in the parent disk. Nitrogen species may be faint, since their favoured condensation domain lies colder still. Dust behaviour carries complementary clues. Polarization as a function of phase angle should hint at compact grains liberated from narrow vents rather than fragile aggregates lifted wholesale from a fluffy surface. The dust-to-gas ratio in the inner coma may be low at first because carbon dioxide flow through capillaries is efficient at moving molecules but not effective at lifting large grains. Sodium emission, often tied to thermal processing of small dust, might be weak or narrowly collimated into a thin tail that reveals modest dust release. Thermal emission from the nucleus should show small, hot spots if vents expose patches of deeper ice under a roof that remains otherwise insulating. Isotope provide a stricte audition. If measurements reach the sensitivity to detect the ratio of carbon-13 to carbon-12 in carbon dioxide lines, values near the galactic mean would affirm a primitive origin without drastic fractionation. Oxygen isotope ratios could encode the temperature and ultraviolet history of grain chemistry in the natal disk. A slight enrichment of 18 oxygen relative to 16 in carbon dioxide, compared with water, would align with laboratory pathways where surface reactions compete under specific thermal regimes. Achieving such precision on a dim, fast traveller is difficult, yet the hypothesis would be startled by a radically non-solar mix. Exotic ratios would send the model back to the workshop. The shape of outgassing should show a geometry set by seams rather than by broad sublimation. Jets would switch on and off with rotation, and with the angle of sunlight on a handful of longitudes. Activity could rise sharply as a critical insulation threshold is crossed, then plateau until deeper layers engage. Non-gravitational acceleration vectors would not point exactly radial from the Sun at all times, but would wander as the active longitudes turn in and out of view. The magnitudes of those accelerations would scale more cleanly with carbon dioxide production than with dust proxies like AF-Rho, since gas flow through capillaries decouples dust lifting from momentum transfer. The bulk properties of the body remain in character under this origin. Density should be low, consistent with a porous matrix that has not compacted under significant gravity. Thermal inertia should be small enough that day-night temperature waves stay shallow. Albedo should be darkened by organics, though not as extreme as the blackest terrains in our own outer system, if the surface has experienced less shock and more gentle sintering. A small increase in albedo on freshly opened vents would be plausible, as bright frost briefly coats exposed walls before recoating with dust. The model also tells a story about timing. At large distances, carbon dioxide activity can begin where water would still sleep, allowing early detection in the infrared before classical water traces rise. Closer to the star, as the seasonal wave penetrates, water signatures should strengthen, and oxygen's red pair should grow relative to the green. If the object rotates in a state close to principal axis, periodicities in carbon dioxide lines should be clean. If tumbling dominates, the periodicities will split and drift, but a persistent preference for those bands would remain until thermal equilibrium shifts the balance. Falsifiability matters. A strong, early, and persistent water signature that scales with continuum proxies in a way typical for local comets would strain the carbon dioxide worldlet scenario. An unusually high carbon monoxide contribution, incompatible with conversion near the carbon dioxide frontier, would also push the idea aside, pointing instead to assembly in a colder annulus. A dense, dust-rich coma launched from broad regions of the surface from the very first approach would suggest a crust without the capillary maze this model relies on. If the evidence gathers in favour, the implications extend quietly. Protoplanetary disks around many stars will have supported annuli where carbon dioxide chemistry on grains flourished. Objects built there can be ejected and wander for ages, then announce themselves with the same hierarchy of gases when they taste new sunlight. That population would be a distinct thread in the tapestry of interstellar debris, not an oddity but a category. A catalogue built over years would then reveal groupings in volatile ratios that map back to different frost lines in many nurseries. The universe would become not only a maker of planets, but a distributor of small archival pieces that remember where they froze. A primitive carbon dioxide worldlet is a humble hypothesis. It claims no marvels beyond the ordinary richness of disk chemistry and the patience of ice. It asks observers to watch for a specific ordering of voices in the coma and for a cadence of activity governed by shallow heating and narrow vents. It offers a picture of interior stratigraphy that explains loud carbon dioxide without demanding the absence of water, and it invites a test that is simple in spirit, even if demanding in practice. Listen to the first gases that rise, map their strength against sunlight and rotation, and see whether water waits its turn. If water waits, the cradle likely stood near a ring of cold, where carbon dioxide taught stone how to breathe first. Time can act like a kiln. In empty space, without air and without mercy, radiation becomes the slow fire, and ice becomes the clay. A small world adrift between stars is exposed to a rain of particles and photons that never ends. Energetic protons slice tracks through its skin. Electrons rattle lattices and break bonds. Ultraviolet light shakes molecules apart near the surface. Micrometeoroids flash small craters into warm glass, and each event leaves behind radicals that search for partners. The result is not a burn, but a curing. Layer by thin layer, chemistry hardens into a veneer that remembers every century. Penetration depths separate the acts in this long play. Ultraviolet fades in the first microns, creating a paint of new organics where carbon chains cross-link and darken. Solar wind ions, when present, reach deeper by tens of nanometers, etching and sputtering. Galactic cosmic rays plunge far below, depositing energy centimeter by centimeter and seeding trails of dissociation. Along those trails, water splits into H and OH, carbon monoxide into C and O, organics into fragments that carry unpaired electrons like open hands. Hydrogen is nimble. It escapes or recombines into H2 that diffuses away, leaving an oxidizing mood behind. Oxygen lingers to marry the carbon that radiation has freed. CO meets O and becomes CO2. OH meets CO and yields CO2 and H. With every cycle, the inventory of carbon dioxide in pockets and coatings increases while the near-surface water budget thins. Sputtering adds a quiet bias. When ions strike, they can eject light species more efficiently than heavy ones. Hydrogen leaves more readily than oxygen, so the crust slowly trades reducing power for oxidants. Peroxide groups accumulate in ice, O2 becomes a trapped guest, and the ambient chemistry leans toward reactions that favor oxide and dioxide products. In this atmosphere without air, oxidants are born from the ice itself, and carbon does not need a free oxygen reservoir to find its way to CO2. The ice manufactures its own breath. Micrometeoroids work as gardeners and masons at once. Each grain that arrives at kilometers per second delivers a microsecond furnace to a patch the size of a grain of sand. Ice flashes to vapor and leaves a foam of glassy, carbon-stained residue. Pores collapse near impact sites, while fractures radiate outward. Over millions of hits, the upper centimeters evolve into a toughened rind, compact where melt has flowed, shot through with brittle seams where stress has relieved itself. This rind reduces permeability for water, which condenses greedily on cold walls and plugs the tortuous passages it tries to use. Carbon dioxide finds the maze less hostile. It sticks weakly and rides pressure gradients more easily, especially along cracks that open at dawn when thermal strain pries old joints. Thermal history folds its own pattern into this fossilizing shell. Far from any star, the body rests near a uniform deep cold. As it nears sunlight, day-night waves warm and chill, only the shallowest layers. That shallow cycling behaves like a vacuum still. Volatiles with lower binding energies are distilled upward and away first, while water is left behind to refreeze in place. Over many gentle periapsis passages in other systems, the same sorting repeats. What remains near the surface is a matrix in which CO2 and certain radiolysis products are mobile, and water is present primarily as deeper stock. The order of the gases that eventually rise is set by a ledger written by old heating, not only by composition at birth. Radiation alters dust as well as ice. Carbonaceous particles evolve toward complex polymers, their optical constants shifting so that red slopes steepen in the visible and near-infrared. Those grains become resilient and compact, reluctant to fragment into fluffy aggregates. When gas flow begins, the dust that escapes is skewed toward small, tough grains and toward fragments born at the edges of cracks, not toward clouds of fragile fluff torn from everywhere at once. Polarization of scattered light tilts toward curves that compact grains prefer. Sodium liberated from thermally stressed grains is present but modest. The coma looks lean in reflected sunlight, compared with its strength in specific gas bands. A thick irradiation mantle is not featureless. Cosmic ray tracks seed weak points. Peroxide and ozone pockets concentrate in tiny domains. Carbonate radicals reside in others. Under a sunrise, these heterogeneities respond like a mosaic. A buried peroxide patch can decompose and release O2 inch a short pulse. A carbonate-rich patch can give up CO2 at lower temperatures than water would choose. Small pressure domes form beneath the crust as gas accumulates faster than it can snake through the pores. When a seam yields, a jet begins with almost no dust, a thin ghost that carries the signature of radiolysis rather than fresh sublimation. This fossil hypothesis makes tangible predictions. A coma dominated early by CO2 should also carry hints of O2 and perhaps H2O2 at levels that are low but correlated with carbon dioxide activity. Forbidden oxygen lines should reflect enhanced photodissociation of radiolytic products near the nucleus, their ratios evolving with distance as quenching relaxes. The diurnal cycle should drive sharp morning spikes, as thermal stress unlocks sealed tracks, with a quieter afternoon when cracks have already yawned and diffusive flow has found temporary equilibrium. Rotational modulation would be strong if a few irradiation seams dominate, and the direction of any non-gravitational acceleration would wander as those seams face the sunday. Isotope effects follow from the slow leak of hydrogen. Where H has been preferentially lost over eons, the residual water near the surface should carry a higher D to H ratio than deeper stock. If vents occasionally cut past the mantle into the interior, a step change in D to H should appear in the water signature. a fingerprint of depth. Carbon in CO the 2nd of May track closer to a primordial ratio, with little fractionation, because its production rides on rearrangements within ice rather than on selective escape. Nitrogen in cyanides could show mild enrichment in the heavier isotope if long irradiation has recycled nitrogen-bearing organics many times. Each of these is a subtle measurement, yet together they mark the difference between ancient processing and youthful assembly. Spectral texture offers a second set of tests. Bands near 3.4 micrometers that belong to aliphatic CH stretch should be visible against a weaker 3.1 micrometer water ice absorption if the surface is rich in radiation-hardened organics. The ratio of aromatic to aliphatic features near 3.3 and 3.4 should sit in a regime typical of long ultraviolet exposure rather than fresh soot. In the mid-infrared, a muted silicate feature can hint at glassy coatings on grains. None of these alone convict the fossil hypothesis, but in concert they strengthen it. Mechanical behavior supplies a third diagnostic. A true fossil shell should resist for long hours, then fail abruptly, releasing small, nearly ballistic puffs rather than a continuous gale. The jets should be narrower than geometry alone would predict, collimated by cracks serving as nozzles. Activity should depend more on stress history than on instantaneous solar power. A rapid change in emission when a particular longitude enters sunlight after a cold night would be a signature of crack-driven venting, not of broad sublimation. If rotation is in a complicated state, the timing of bursts may drift slowly as stress patterns migrate across seams. That wandering will write a beat into the gas that does not match a simple day. Laboratory physics supports the plausibility of these scenes. Mixed ices of water and carbon monoxide sliced by ions make carbon dioxide and leave peroxide behind. UV broken organics darken and develop the signature vibrational modes seen in astrophysical dust. Irradiated ice loses hydrogen and gains oxygen-rich functional groups. Micrometeoroid analog impacts compact powder and produce thin glass that is harder to permeate. These are small truths under controlled lights, but their directions line up with what a fossil surface would need. Energy balance argues that a processed crust can persist. The heat required to erase the mantle and expose fresh ice is large compared with what a brief warming at a single star can deliver to depths of many centimeters, especially when thermal inertia is small. A limited season in sunlight rearranges frost and releases trapped gases from shallow traps. It does not remake the object. In this view, the observed chemistry is the echo of millions of years, not the script of a single year. A skeptic will ask for a clean dividing line between this fossil picture and alternatives. The answer is to look for signatures that require radiation rather than merely allow it. Oxidants coupled with CO2, depth-sensitive isotopes, morning-dominated bursts from the same longitudes, polarization curves consistent with compact grains from cracked roofs, and a dust-to-gas ratio that stays low until a structural failure opens a deeper throat. If these emerge together, the simplest reading is that light and particles have written the surface into a textbook that now recites CO2 first. An irradiated fossil is not a romantic embellishment. It is a sober way to understand why a small body can exhale carbon dioxide while holding its water, why jets can be narrow and fickle, why colours lean red and dust remains shy. Time has been the artist. Radiation has been the chisel. The statue that remains breathes in a voice trained by exposure, a voice that sounds alien only because it has practiced for so long in the cold. Imagine a small world wrapped in its own winter coat. The coat is not cloth. It is a layer of desiccated dust, sintered grains, and polymer dark crust that grew from its own breath. Every time sunlight warmed the surface, ice beneath vaporized and dragged fine particles towards space. Gravity tugged some back. They fell in slow arcs and settled like soot. Larger bits landed first, small ones sifted later, and the jumble compacted under its own slight weight. With each cycle, the blanket thickened. Heat could no longer travel freely downward. The world learned to keep its cold, and the cold learned to keep its water. This insulating mantle sets a temperature ladder inside the nucleus. At the top, illumination raises the skin by tens of degrees. Then the gradient falls sharply across a few centimeters, and below that, the old cold sits almost untouched. Where the gradient is steep, vapor meets a trap. Water that tries to rise meets cooler pores and condenses, coating walls as microfrost. Each condensation releases latent heat into those walls, but the heat spreads poorly, and refrozen water chokes narrow passages like ice in a sieve. Carbon dioxide behaves differently. At the same temperature, it condenses less readily, and where the mantle is warm enough to forbid its refreezing, it keeps moving. The result is a distillation column written into rock powder. Water distills down, carbon dioxide distills up. Flow through such a matrix is neither bulk wind nor simple seepage. In coarse regions, gas obeys Darcy's law, sliding through tortuous channels like air through a sponge. In fine regions, the mean free path exceeds the pore size, and molecules ricochet from wall to wall in Knudsen diffusion. A mantle made of both regimes in patchwork acts as a filter that selects by mass, sticking probability and temperature. Water molecules are more likely to stick, more likely to refreeze, and more likely to clog. Carbon dioxide is more likely to slip. A shallow network of connected pores becomes a set of chimneys that carry carbon dioxide from deeper horizons to space, while water remains locked beneath a bright but brief season. The structure is not static. Sintering welds contacts between grains where the mantle warms, slowly closing micro doorways. Sublimation shrinks grains and leaves cavities that conjoin to make new roots. Microgravity makes landslides easy. A sheet of dust can creep, settle, and shore up gaps like a plumber sealing leaks. The mantle is a living architecture, always adjusting. In time, the pathways that favour carbon dioxide become straighter and smoother, because gas that flows along them scours, while gas that fails to flow leaves deposits. The selective plumbing strengthens itself. At depth, sublimation fronts retreat. A front is the interface where ice meets vacuum, threaded through pores. For carbon dioxide, the front sits higher because less heat is needed. For water, it sits deeper because more energy must arrive, and because much of the flux is captured and refrozen along the way. As the body approaches the star, the carbon dioxide front advances toward the mantle, then stalls behind the insulating layer. Pressure builds under the blanket until the weakest throat opens. At that moment, the mantle behaves like a valve. Gas jets outward from a handful of vents while everywhere else remains quiet. Water contributes little until the season grows stronger or until a structural failure cuts past the sealing frost and reaches the deeper shelf. This mantle establishes a feedback loop that keeps water hidden. Vapor that does escape from the waterfront cools as it rises into colder pores and refreezes, thickening the very plug that resisted it. That is cryosaling. Every successful passage for water degrades the next one. Carbon dioxide does not suffer the same fate until the mantle cools again or the distance from the star increases. Hence, the coma speaks in the voice of carbon dioxide early and often, and water clears its throat only later, or in episodes when a crack threads the mantle with a lucky angle. Mechanical properties reinforce the pattern. The mantle's tensile strength is low in absolute terms, but high compared with the weight of material it supports. Because gravity is weak, a centimetre can hold a roof if the pores are stitched by organics, and if micro-ice glues the grains. Thermal stress concentrates along inherited seams. Morning and evening cause expansion and contraction that pry those seams by hairbreadths. When a seam connects a deep pocket with a near-surface warm zone, a chimney opens. If the seam only crosses cold territory, frost thickens and the plug returns. The body breathes according to this grammar of intermittent valves. Dust behavior reflects the same selective plumbing. Carbon dioxide that escapes through narrow vents accelerates grains only if the grains are small enough to be caught in the stream. Coarse particles stay. Fine ones go, but in small numbers, because the jet is narrow and choked by walls that absorb momentum. A coma fed this way looks gas-rich and dust-shy. Polarization of scattered sunlight hints at compact grains liberated at crack mouths rather than fragile aggregates lofted from wide terraces. Sodium emission, which often betrays thermal stress in small grains, remains narrow or faint, confined to thin rays aligned with the strongest chimneys. Thermal emission from the surface becomes patchwork. The mantle hides the heat from most places, so the brightness temperature reads low and uniform. Vents, however, blaze in infrared as tiny hot spots where latent heat from sublimation and friction in the flow adds to sunlight. If an instrument resolves nothing, the hot spots dilute into a mild excess at certain longitudes. If the beam is fine enough, it can see the spots wink on and off with rotation, giving a direct count of active chimneys and a measure of their duty cycle. Non-gravitational acceleration aligns with the plumbing more than with a neat radial picture. When the vents point roughly away from the sun, the push looks classical. When mantle geometry aims the chimneys sideways, the direction of the push rotates with the nucleus. That rotation can be used to infer the locations of vents relative to the spin axis, and to deduce how deeply the mantle controls the flow. If the same longitudes produce thrust day after day while the magnitude changes with distance from the star, the mantle owns the script. If new vents appear after landslides or outbursts, the script is being revised by structural change. This insulating hypothesis leads to observational tests. Carbon dioxide lines should turn on at larger distances than water. Hydroxyl, the child of water, should lag in time and grow with clear thresholds as cracks finally connect the deep front to the sky. The forbidden green line of oxygen near the nucleus should compete strongly, because carbon dioxide photodissociation seeds it efficiently where densities are still high enough to matter, but not yet high enough to quench. Dust production should be non-linearly related to gas production, increasing sharply only when vents widen or when the mantle fails. Millimeter maps of molecules should show jets thinner than the continuum halo, because gas fits where dust often cannot. There are seismic consequences at small scale. As gas escapes through a throat, it exerts drag on the walls. The stress can widen the crack, but it can also ease shear and cause local collapse that buries the mouth in fresh debris. That self-choked vent then falls quiet until pressure rebuilds. A cadence of flare and fade follows naturally, with periods tied to the time needed to refill pockets and to the rotation that brings the same seam back into sun. A long watch would record this cadence as beats superposed on the larger seasonal crescendo toward perihelion. The hypothesis also suggests what would contradict it. A broad, early water coma proportional to sunlight, with dust flowing freely from many latitudes, would be unfriendly to a strong mantle. A polarization curve pointing to fluffy aggregates lifted in great number from wide plains would also challenge the idea. So would a non-gravitational acceleration fixed nearly radial over many rotations, implying diffuse activity rather than chimneyed thrust. Such outcomes would push the story toward a more permeable crust or toward a nucleus without a significant insulating blanket. If supported, the mantle picture offers a gentle explanation for loud carbon dioxide without dismissing water. The body is not alien in bulk. It is edited at the surface by its own history. The editing converts a mixed interior into a selective voice. Under a scant atmosphere of dust, water becomes the quiet organ bass, carbon dioxide the silver flute. The music changes when a bolt of stress breaks the stops and the deeper registers surge. Until then, the instrument favors high notes. The beauty of an insulating mantle is its humility. It relies on no exotic composition, only on familiar processes repeated patiently. Fallback, compaction, sintering, frosting, cracking, and the stubborn arithmetic of latent heat. Together they make a blanket that both preserves and censors. A traveller wrapped in such a coat can cross light years and then speak in a narrow accent when it enters a new sun. Listening for that accent is within reach. It lives in line ratios, in the timing of flares, in the shape of polarization curves, and in the slow drift of thrust direction across a few patient nights. Imagine a traveller that wears a costume of frost and dust. The costume is not only to keep warm, it is a veil. Its purpose is to make a deliberate craft pass for an ordinary small world. In this thought experiment, the veil is engineered from carbon dioxide ice, layered with dark grains, chosen because it will speak in spectral lines that astronomers understand and expect. The veil sheds gas when sunlight arrives. It throws a small cometary coma. It even forms faint jets. Yet underneath the theatrics sits hardware with a plan. The question is not whether such a thing exists, but how nature and artifice could be told apart if a mind somewhere chose to hide intent inside a familiar breath. Motives shape designs. A veil could be camouflage, allowing an instrumented probe to enter a planetary system without announcing technology. It could be thermal shielding for delicate sensors that must watch a star at close range. It could be propulsion, since controlled sublimation provides reaction mass without tanks, if a store of ice is part of the hull. It could be a brake for a fast interstellar arrival that needs to shave velocity using sunlight and gas. It could be a relay, parking along the line of a gravitational lens to drink a torrent of magnified photons. Any such motive would require patience and thrift, the virtues of a craft that runs for months with only light and frozen carbon to spend. Architecture follows motive. The veil might be a caged shell of porous panels packed with carbon dioxide ice and seeded with dust. Microchannels would run through each panel, narrowed by sintered throats acting as valves. A thin layer of radiation, darkened organic polymer, would turn sunlight into heat with disciplined efficiency. Embedded heaters could tune the flow when starlight alone proves fickle. The panels would hinge like petals, opening to increase area to mass ratio when radiation pressure is needed, and closing when a smaller sail is wiser. Beneath the panels, a rigid truss would keep mass concentrated toward the center, a trick that helps hide hardware inside a cloud of gently escaping molecules. Dynamics gives the first discriminants. Natural jets answer to sun, angle, and local temperature. An artificial veil would aim thrust even in darkness by storing gas and venting it later. A measured push that holds a nearly constant direction in the star frame, despite rotation and changing illumination, would be suspicious. Torques can be engineered as well. Reaction wheels or sublimation vanes could maintain a preferred attitude that fights the tendency to tumble. The light curve would still breathe with facets and shadows, but a slow precession that aligns with thrust requirements rather than with thermal physics would betray a pilot, even a careful one. Thermal maps add a second set of tests. Natural surfaces show hot spots tied to vents and to slopes that bask in morning light. A veil with embedded plumbing can radiate heat from deliberately chosen patches that do not match insulation. Infrared images would then find uniformity where unevenness should live, or find concentrated warmth on the night side where stored gas is being pushed through nozzles. Waste heat from electronics is small compared with sunlight, yet if it is routed through regular radiators, the spectrum can show unnaturally smooth blackbody patches on a canvas that is otherwise lumpy and cold. Spectra carry the third set of clues. A veil built to read like a comet would exhale the expected lines of carbon dioxide and its children, but the details matter. Natural chemistry throws a family of fragments and daughters whose ratios change with distance from the nucleus and with solar activity. An engineered mixture might be too pure, or it might present narrow line widths from collimated microjets that do not widen with the relaxation expected in free expansion. Isotopes are stubborn witnesses. Highly refined carbon dioxide would carry ratios tuned by industry, not by stardust. Conversely, a veil built from harvested ice would track cosmic norms, and only time series would help. Modulation is a stronger tell. Gas release pulsed at prime intervals, or at intervals keyed to a mathematical sequence, would look like a heartbeat that physics has no reason to keep. Dust is a patient interrogator. Natural may contain a wide size distribution, and the polarization of scattered light maps that distribution into a smooth curve versus phase angle. An artificial veil could favor monodispersed grains, chosen for optical or thermal reasons. The polarization curve would kink instead of glide, or it would repeat a shape at several wavelengths with an invariance rare in nature. Specular flashes from flat flakes would add brief glints to a light curve otherwise governed by roughness. Radar would probe deeper. A cross-section that spikes at specific geometries, repeating with the precision of a rotating truss, would lean away from geology and toward craft. Trajectory supplies a subtler audit, a path chosen to pass through particular gravitational keyholes, not for maximal deflection but for precise outbound aim, would reveal foresight. A threading of planetary encounter windows that avoids close passes while still extracting a desired turn looks like chess, not drift. A leisurely loiter near the line of a gravitational lens focus, or a bend that sets the craft on that line afterward, could be written off as luck once, but a sequence of such moves builds an argument. The energy budget is the governor here. Every correction costs mass or momentum. If tiny, steady nudges appear when sunlight cannot explain them, a reservoir of compressed gas or a sail hidden in dust must be invoked. Signals tempt the ear, yet prudence is strict. A narrowband radio carrier would be decisive, but silence is more likely if concealment is the point. Other channels remain. High-cadence spectroscopy could search for microflicker in line strengths that encodes numbers. Photometric microvariability could carry phase-keyed pulses buried under ordinary rotation. Polarimetric position angles could precess according to a count that mathematics would recognize. None of these would be conclusive alone. Together they would make a pattern, and patterns that lean on low complexity are hard to fake with geology. Plausibility sets limits. Sunlight can push, but the push is slight unless area per mass is extravagant. A veil that relies on radiation pressure would need membranes thin as a whisper, yet those membranes must survive dust impacts and thermal cycling. Controlled sublimation is more forgiving, yet it spends mass. To keep thrust for weeks, a store of carbon dioxide must be substantial. A craft the size of a house could hide such a store inside an envelope the size of a small hill, but the veil would shrink, and the coma would thin in ways that careful photometry could track. If the flux of gas falls smoothly according to the amount needed for the observed accelerations, motive and means are in step. If accelerations persist while production does not, nature is the safer culprit. Ethics touches the edge of the mirror. Minds long for a sign. Minds also respect the discipline that keeps signs honest. An artificial veil is a hypothesis that must earn its keep by surviving null tests. Map jets against sunlight and rotation, and ask whether thrust follows the map. Weigh line widths against distance, and ask whether collisional regimes evolve as kinetics demand. Compare polarization with the canon written by dust from many comets, and ask whether the curve lives within that envelope. Search for coding, but expect none. Above all, invite failure. The hypothesis should be easiest to break where it is boldest. There is a quieter possibility, ambiguous and human. A veil could be art, a gesture rather than a stratagem, a way of entering an unfamiliar sky without putting fear into those who watch it. If so, the veil would choose familiarity over invention, and its seams would be sewn to mimic faults, not to display skill. Only a small kindness would betray it. Perhaps the decision to linger where instruments can see, or the restraint to keep thrust gentle when the easy path would risk a planet. Such kindness would be indistinguishable from chance in the first telling, and perhaps in the second as well. In the end, the idea of an artificial veil is a laboratory of imagination that still respects measurement. It invites observers to sharpen the watch for thrust divorced from heat, for chemistry that carries rhythms rather than weather, for dust that behaves like designed material rather than eroded stone. If nothing unusual appears, humility wins, and natural explanations learn new strength. If something holds after careful assaults, the sky gains a question large enough to change how instruments are pointed for generations. Either road leads to better listening, either road keeps wonder honest. Two mirrors wait in different darkness. One circles Earth inside a sheath of night and dawn. One keeps station far beyond the magnetosphere, quiet at a cold point where the sun and Earth share custody of gravity. Together they listen, not with ears, but with diffraction and silicon. Their task is simple and severe. Read breath that is almost nothing and turn it into facts. Hubble tastes the short waves. Its cameras and spectrographs open the ultraviolet and visible where coma chemistry writes bright, narrow alphabets. A slit set across the hazy head resolves the violet bands of cyanide near 388 nanometers. A filter tilted to 308 nanometers admits the faint glow of hydroxyl, the quick child of water. The forbidden oxygen lines shine like careful punctuation. Green at 557.7 nanometers, red at 630.0 and 636.4. Decarbon cuts green slashes at 516 nanometers. Sodium doubles at 589. Ions braid blue with carbon monoxide ion near 426 and molecular nitrogen ion near 391, following the solar wind like iron filings along a field. With these letters, Hubble makes maps, long, narrow images where intensity falls with distance from the nucleus in ways that photochemistry predicts. Where the fall is slower, production is higher. Where the fall bends, quenching and collisions are at work. Polarization adds texture. Rotating polarizers in the optical draw curves of fractional polarization versus phase angle that betray grain size and structure. Compact processed grains push the curve one way. Fragile, Fluffy aggregates bend it another. When the coma is thin, even a few % of polarization carries weight. Sodium's narrow tail sometimes stands apart from the dust, a pale harpoon down the anti-solar line. Its presence or absence hints at the thermal handling of small grains that break, flash, and release atoms. Webb drinks the long waves. Near-infrared spectrographs prize the fundamentals and overtones of water at 2.7 and 6 micrometers, carbon dioxide at 4.26 and 15, carbon monoxide at 4.67, methanol and formaldehyde in dense thickets across 3 to 5. Mid-infrared instruments reach the 10 micrometer silicate plateau, the place where grains confess composition by the shape of their thermal glow. Imaging through grisms builds low-resolution spectra across the head and along jets, a way to separate molecular light from dust continuum without losing spatial context. Line shapes widen by tens to hundreds of meters per second, a measure of outflow speeds. Ratios among bands transform into production rates when models account for pumping by sunlight and the thinning of gas with distance. Both observatories track moving targets with care. Pointing must follow a rate that is not sidereal, the sky's ordinary pace, but the comet's own glide. Slits are aligned to the Sun-comet vector so that photodissociation daughters fall along the long axis of the aperture. Dithers step the image to chase hot pixels and soften the imprint of bad columns. Exposure times walk a line between signal and smear. The nucleus is not allowed to saturate. The coma is not allowed to disappear into read noise. Each visit anchors an epoch, and the epochs stitch into a light curve and a chemical diary. Data begin as counts and end as stories. Dust continuum is fitted and subtracted from spectra so the bands of gas can stand alone. Fluorescence efficiencies, the G factors that say how bright a molecule is under a given solar condition, are applied. Lifetimes against sunlight are folded in so that parents and daughters can be separated. Models test whether a simple spherical flow suffices or whether jets must be drawn into the picture. Weather in the coma is reconstructed from a handful of lines that change with time and with position, a low-pressure meteorology of expansion, quenching, and shadow. Hubble's gift is tracing the descendants of the chemistry. Hydroxyl speaks for water's output near the surface, cyanide for parent hydrogen cyanide that broke a few thousand kilometers out, dicarbon for organic chains cooked by sunlight into smaller links. Oxygen's forbidden lines report which parents are being torn. Ratios change with distance because collisional quenching falls away, and because the balance of parents changes with time of day on the nucleus. A panel of those lines drawn as a function of radius becomes a diagnostic table where the coma's heartbeat can be read. Webb's gift is reading the parents themselves. Carbon dioxide's fundamentals are invisible from the ground. In space they write blazing bars at 4.26 micrometers and a broad shoulder near 15. Water's bands speak plainly. Carbon monoxide's lines provide an independent measure of cold inventory. Methanol's comb shows how hydrogenation proceeded on grains in the natal disk. The silicate emission around 10 micrometers tells whether grains are crystalline or glassy, whether they grew by sticking or by melting and quenching, whether they wear organic coats that mute sharp features. Thermal imaging of the nucleus under the coma offers temperatures that imply thermal inertia, a way to weigh how fast heat travels into the skin. Timing reveals mechanism. If carbon dioxide lines rise early at large, heliocentric distances while hydroxyl waits, shallow heating and selective plumbing are likely. If hydroxyl increases in step with continuum in a broad, smooth way, water is engaging across wide terrain and crust is less censoring. If oxygen's green line near the nucleus rivals the red pair, carbon dioxide photodissociation is dominant close in. If the red pair grows with radius, water takes over farther out as density falls and quenching relaxes. Line widths that swell and shrink with rotation imply vents that spin into and out of view. Flat widths imply broader, more uniform escape. Spatial structure deepens the case. Long slits set radial to the sun show fans and sheets. Perpendicular slits catch sideways jets. Interferometric mapping does not belong to these observatories, yet their spatially resolved spectra still sketch cones of emission that track the geography of activity. Comparing the geometry of carbon dioxide with that of hydroxyl tests, whether the same longitudes feed both species. If they do not, carbon dioxide may be finding narrower throats that water cannot enter at the same temperatures. Rates measured at different wavelengths, cross-check assumptions. Gas production inferred from carbon dioxide fundamentals should predict a minimum non-gravitational acceleration if thrust is the source of any measured deviation in the orbit. If acceleration exceeds what gas can provide, dust, recoil, or radiation pressure on sails of unknown origin must be invoked. If acceleration falls below the gas prediction, geometry or mass have been misjudged. Thermal models that fit mid-infrared fluxes and near-infrared reflection together limit size and albedo. The allowed pairs of radius and reflectivity collapse into a small patch once Webb's warmth and Hubble's reflected light are married. Photometry still matters. Hubble gathers visible light curves that record rotation, hints of tumbling, and phase effects that reveal dust properties. Webb's time series at 2 to 5 micrometers adds the response of warm grains and hot spots. The combination breaks degeneracies. A large amplitude in the visible with a modest amplitude in the thermal suggests albedo patterns or jets, not extreme shape alone. A thermal spike unaccompanied by a visible spike signals a vent turning on without a correlated avalanche of dust. Practical limits set the art. Solar elongation constraints dictate when Webb can look. Earth's limb and orbital day-night cycles shape Hubble's schedule. Backgrounds change, with zodiacal dust and with the temperature of the telescope itself. Lines blend. Telemetry budgets are finite. Plans find room in these constraints for repeated visits with carefully chosen cadence. A slow sequence sees seasonal trends. A fast burst across one rotation sees vent choreography. When the measurements are reduced, certain questions find sharper edges. Which gases lead, and by how much? How does outflow speed depend on species? Do jets persist at fixed longitudes, or do new vents appear? Is the dust distribution narrow or broad? Do oxygen line ratios track the mix of water and carbon dioxide in a way that changes with radius? Does a small thermal inertia betray an insulating blanket? Does a high ratio of carbon dioxide to water ask for a cold birthplace? The answers rarely arrive as single numbers. They arrive as bands of confidence that narrow with each pass of the telescopes and with each night of careful bookkeeping. Glass does not feel, yet the process looks tender. A mirror in low Earth orbit measures a green line that began as a bond broken by sunlight. A mirror at a Lagrange point measures a vibrational glow that began as a molecule shaking itself free at the mouth of a pore. From such quiet signals, a path toward understanding is built. Motion is fitted. Chemistry is weighed. Temperature is inferred. A traveller that never says a word is heard anyway, because light is a language and instruments are patient translators. Chasing a fast, dim body asks for humility and nerve. The quarry is small, the ephemeris young, the brightness fickle, and the clock impatient. Flight dynamics is not an art of bravado here. It is an art of readiness. The first requirement is simple to say and difficult to fund. A spacecraft must exist before the alert arrives, fueled, tested, and waiting where departure is easy. Parking at the Sun-Earth L2 point gives that readiness the cleanest stage, free from atmospheric drag and launch pad weather, close enough to Earth for communication, far enough to slip away with a modest burn. From such a waiting room, an interceptor can pivot within days, not years. Geometry decides ambition. The visitor carries a surplus speed at infinity that belongs to other suns. Against the Sun, that surplus may be 30 kilometers per second, perhaps more. Against Earth, it may be higher or lower, depending on the angle of approach and the month of the year. Closing that gap is not required. Meeting is required. The craft's outbound path can be chosen so that the relative speed at encounter is survivable for instruments, even if it is still violent by human standards. 10 to 20 kilometers per second is a sweet spot for imaging and spectroscopy if the pointing is disciplined, though designs have been sketched for faster crossings. Delta V budgets then trace back from that choice. A few kilometers per second may suffice for a staged mission at L2 if the alignment is kind. If it is unkind, creative maneuvers appear. The classic trick is an Oberth burn near a star. Chemical engines that feel weak in deep space become briefly fierce when they fire at perihelion, because the ship is moving faster and kinetic energy grows as the square of speed. A trajectory that drops inward toward the sun, skims a safe perihelion, and spends propellant at the bottom of the well can steal added velocity from the star's field. Thermal protection then becomes a gating technology. A vehicle must shrug off sunlight at intensities many times higher than near Earth, without boiling propellant or blistering its eyes. If that hurdle can be cleared, the path broadens from L2 to the whole inner system. Venus flybys and Earth swingbys add further options, each one trading time for speed. Electric propulsion tempts with thrift. Ion engines and Hall thrusters sip xenon and pay it back with months of gentle push. Their gift is flexibility. A craft can retune its path as the ephemeris improves, shaping arrival geometry to favour a sunlit hemisphere or a longer dwell at useful phase angles. The price is patience and power. Arrays must be large. Pointing must share time between instruments and thrusters. And the plume must not contaminate mirrors that need to read faint gas. A hybrid approach often looks best. Chemical burns set the broad strokes. Electric thrust writes the fine lines. Navigation is the quiet heart of the chase. The target is unresolved until late. Ground-based tracking refines the path every night. But final certainty arrives only when the interceptor's own cameras catch a moving fleck against a star field. Autonomy becomes essential in the last hours, as light travel time makes teleoperation obsolete. Optical navigation algorithms lock onto the object and predict its next position with a Kalman filter that blends dynamics with shrinking uncertainty. Star trackers cross-check attitude, while bright limiters protect sensors from the sunday. Thrusters nudge the line of sight, so that the fleck remains near the center of a gimbal that keeps instruments steady as the bus slews. Encounter strategy is a choice among risks. A single close pass by a main craft is simple and courageous, yet the relative speed can turn seconds into the entire science window. A carrier that splits into subprobes near approach softens the risk. One probe can dive sunward to taste the coma head-on, another can swing tailward to catch dust and ions downstream. A third can keep distance and act as a relay while watching the entire geometry evolve. Each subprobe accepts a different hazard profile, and together they build a stereoscopic picture that a lone bus cannot. Separation events must occur early enough for the small craft to drift into their lanes without extravagant burns. Instruments favor speed and certainty over elegance. A narrow-angle camera with rapid frame transfer freezes motion in exposures measured in milliseconds, trading photon hunger for sharpness. A wide-angle imager rides shotgun to ensure that the target never slips off the slate. A near-ultraviolet spectrograph reads hydroxyl and cyanide at high cadence. A near-infrared spectrometer watches water and carbon dioxide fundamentals, accepting that high resolution might be impossible at maximum rates and choosing instead to interleave modes. Dust analyzers sit behind Whipple shields, counting impacts and weighing grains by time of flight mass spectrometry. A small magnetometer on a boom listens to the interaction of ion tail and solar wind. A plasma package senses the pickup ions that betray which gases have become charged. Pointing rules are written like vows. Keep the sun outside a narrow angle. Keep the target inside a wider one. Never saturate the detector during the seconds of closest approach when brightness spikes. Warm spectrometers only on the far side of the pass when radiant flux relaxes. Turn the high-gain antenna away from instruments only when buffers are full and a window opens for downlink. Priority lists decide what survives if memory fills. Raw images of the nucleus take the throne. Next are spectra near the peak of activity. Tails and context come later. Compression is ruthless, but lossless for the crown jewels. Shielding carries its own poetry. At 10 kilometers per second, a sand grain has the energy of a rifle bullet. A forward bumper separated from the pressure vessel by a gap turns grains to plasma, then to dust, then to nothing. Edge-on profiles minimize cross-section during the most dangerous seconds. The path itself can duck through the coma at an angle that keeps column density modest while still tasting gas. Models predict safe corridors, yet they are models, and the craft must be built to forgive the sky its surprises. Communications plan around silence at the moment of truth. There is no real-time feed while the bus whips through closest approach. Telemetry is written to solid-state memory with generous margins, time-tagged with atomic accuracy, and played back when geometry allows. Deep space stations on Earth and partner networks trade passes to keep the downlink steady. Bit error correction and packet interleaving guard against fades. The bus speaks first, the subprobes later. If a probe does not call home, a trailing camera's record still preserves the cross angles needed to reconstruct shape and jets by inversion. Science return depends on choreography more than on any single instrument. A burst of images across a span of phase angles lets shape models blossom from light and shadow. Spectra taken both sunward and tailward tell whether gases emerge from specific longitudes or as a sheet, dust impact rates compared with brightness pinned down dust to gas ratios. A magnetometer's trace, as the craft skims field lines, constrains ion densities without seeing them. Every dataset is thin by itself, thick in concert. There is also a plan for retreat. After the pass, the bus must survive. Outgassing from its own warm panels can confuse instruments if exposures continue without pause. The first minutes after encounter are for safing, cleaning optics by pointing them at cold space, heating vulnerable elements to drive off frost only when it is safe, and letting reaction wheels spin down from the violent sloughs they endured. Only then does the downlink begin in earnest. Only then do commands for any second pass, if geometry permits, rise from ground to sky. Small auxiliaries make the difference between missing and knowing. A CubeSat released days ahead can take the role of a slow scout, mapping the coma at leisure and relaying a refined ephemeris to the main craft. A solar sail drone can loiter for weeks at favourable angles while the heavy bus arrives for its sprint. A radio beacon left on a trailing orbit can triangulate the nucleus with simple timing against Earth and the main craft, improving navigation beyond what optics alone can do in glare. Ambition must be tempered by the one-chance truth. A reckless dive that risks the bus for a glamour shot may spend decades of preparation for a few blurred frames. A cautious pass that respects pointing limits and shielding may feel modest, yet it returns spectra, shapes, and fields that will still be read when fashions change. Mission design learns to honor patience dressed as bravery. The Ghost is not hunted by speed alone. It is caught by readiness, by geometry, by autonomy, and by the vow to bring the story home in data that outlive the thrill. Chance wears many masks, and the mind mistakes them for faces. The mathematics of being chosen begins by removing the masks, one by one, until a quieter expression remains. The stage is simple. Rare events flow through time like a thin rain. Instruments notice some of them, miss others, and from the noticed, few stories are told. The first tool for such rain is a clock that measures waiting. If arrivals are independent, and the mean rate is steady, the gaps obey an exponential law. Short gaps are common. Very long gaps are uncommon but inevitable. Surprise grows when the rate is unknown, but that ignorance is part of the model. It can be treated as a parameter with a prior, updated by each new detection. The posterior widens or narrows according to the facts. The lesson is not romantic. Waiting times often feel meaningful simply because the human pulse wants rhythm where there is only chance. Expectation must then be folded through the lens of detection. A telescope has a probability of seeing that changes with brightness, rate of motion, and sky position. That probability can be written as an efficiency curve, often resembling a softened step. Faint things are ignored, brighter things are welcomed. Between those extremes is a slope where many candidates live. The true arrival process is multiplied by this curve. The result is a stream of discoveries that is not uniform even if the cosmos is. A spike in the stream can be a step in efficiency that went unnoticed. A lull can be weather. Mathematics demands that feeling make room for calibration. Geometry adds more structure still. Paths are focused by gravity. Speeds are drawn from a distribution that belongs to the local river of matter. The sun prefers to bend slower passes more deeply, so the flux near the inner region is biased toward a velocity tail. The Earth adds its own modulation as it moves around the star, changing the night sky where surveys are sharpest and altering the angles at which approach can be seen. These factors can be computed. When they are, A pattern that felt like selection turns into a profile that felt inevitable to the equations. Yet, even after calibration, coincidences remain. The question becomes how to measure surprise honestly. Statistics offers a scale that does not depend on mood. For any hypothesis, h and data d, the log of the likelihood, written as log p of d given h, tells how compatible they are. Compare two hypotheses by the difference of those logs. The larger the positive difference, the stronger the weight of evidence. In this way, a claim such as timed arrival can be framed as a hypothesis that carries more structure than a null model. The structure might be a preferred season, a preferred direction, or a cadence tied to a human calendar. If the data lift the structured model above the null by only a few units of log likelihood, the evidence is modest at best. Gravity and survey cadence often win such contests by long margins because they place structure where nature actually lives. Complexity acts as a penalty that keeps imagination honest. Models with many knobs can fit any noise. The discipline adds an Occam factor, a term that downweights models with large, flexible parameter volumes that are not used by the data. Bayesian evidence embodies this idea. It averages the likelihood over the allowed parameter ranges, not just at the best fit. A model that wins only at a narrow, contrived setting loses when the average is taken. In practice, this punishes stories that find meaning in a single date or a single angle chosen after the fact. The look elsewhere effect is the most patient adversary of false meaning. A pattern found by scanning across many possibilities must pay a tax for the search. If 1,000 alignments are tested, a few will look better than chance, even when chance rules. Correcting for this search is simple to describe and easy to neglect. One computes a global p-value by simulating many worlds under the null, applying the same search, and counting how often a pattern at least as strong appears. A shortcut uses the Bonferroni bound, multiplying a nominal p-value by the number of trials. The shortcut is crude but safe. The simulation is tender and exact. Anthropic selection enters like a quiet chorus behind the foreground mathematics. Observers exist only when and where conditions allow them to build tools and to care. That condition biases the sample in subtle ways. A civilization will tend to notice rare arrivals during the era when it has surveys, not before. It will tend to assign meaning to events that follow its calendars and anniversaries, not those of a species elsewhere. The Copernican posture asks for modesty in the face of such bias. The correct question is not why now, but what fraction of similar civilizations at similar technological moments would also see an arrival within a similar span after they became able to look? When that question is asked, the answer often moves from uncanny to ordinary. Information theory offers a measure of pattern that is immune to charm. A signal carries meaning if it reduces uncertainty. Mutual information quantifies that reduction between two variables, such as arrival time and a candidate pattern. If aligning arrivals with a calendar does not reduce uncertainty beyond what the null model already sets, then the pattern is decor, not content. Kolmogorov complexity frames the same intuition differently. A sequence is meaningful if it can be compressed into a short description. Prime numbers compress to a rule. Noise does not. An arrival that can be described only by listing its date is not more compressible than any other. Selection bias contaminates practice even when models are pure. The most obvious cases are publication bias and attention bias. Striking coincidences are written about and remembered. Modest confirmations of expected rates are filed and forgotten. The cure is registry and pre-commitment. Declare in advance the test to be applied, the data window to be used, the number of trials to be scanned, and the threshold for calling a deviation interesting. The registry locks the door that p-hacking would otherwise breeze through. Pre-commitment honors the reader with honesty about how many times the dice were rolled. Resampling serves as a purifier when pre-commitment was impossible. Shuffle months while keeping years fixed. Rotate sky coordinates by random longitudes while preserving latitudes. Draw bootstrapped catalogues that mimic the survey's cadence but break any specific human pattern in the original data. If the observed alignment persists across shuffles, the pattern has teeth. If it dissolves, it was born of choice rather than of cause. Such shuffles can be designed to preserve every constraint that nature enforces, while removing only the one the mind hopes to test. Hazard functions add nuance. that ordinary rates cannot. A hazard is the instantaneous chance of an arrival given that none has yet been seen by a certain time. If the hazard rises slowly as surveys improve, a detection shortly after instrumentation crossed, a threshold is not eerie, it is predicted. A failure to include this time dependence in the prior inflates surprise unfairly. Survival analysis, borrowed from fields that study lifetimes, becomes a narrator of our own readiness as much as of the sky's behavior. Extreme value theory curbs exuberance about records. The biggest, brightest, fastest, or most aligned arrival in a catalogue will always look remarkable because it sits at a tail. Tails have their own laws. Maxima drawn from many samples follow distributions with known forms. Seeing one object that breaks a previous record by a modest margin often tells us nothing except that the sample size grew. A careful analyst plots records against sample number, not against calendar year, and the trend becomes sober. Geometry offers a final tutor. If arrivals seem to cluster near the direction of solar motion around the galaxy, the first hypothesis is not aim. It is drift through a river. If they favour months when a particular survey has more dark time, the first hypothesis is not choice. It is duty roster. If an approach brushes a keyhole that would set up a return centuries hence, the first hypothesis is not message. It is the dense lattice of gravitational possibilities that fill space with invisible doors. Reason does not ban amazement. It reallocates it to structures that deserve it. None of these tools are enemies of wonder. They are the scaffolding that lets wonder climb without falling. When a pattern survives correction for search, when it reduces uncertainty by a measurable byte, when it compresses into a short rule, and when it continues to hold under resampling that scrambles everything except the suspected cause, then the word chosen can be spoken without apology. Until then, the word is a metaphor that belongs to poetry, while numbers do their steady work. There is a grace in this discipline. The mind comes prepared to be moved. Mathematics teaches how to be moved for the right reasons. Behind every coincidence, there is either cause or counting. Counting is not contempt. It is the way laws of chance write their own style on the page of a life. A rare arrival might feel like a finger-pointing. The analysis that follows may reveal a hand of geometry, a wrist of survey cadence, and an arm of patient statistics. The gesture is still beautiful, just beautifully explained, meaning moves like tide water along a shoreline of fact. Gravity lifts the ocean and then sets it down, and in the same rhythm thought rises over data and recedes. The instruments speak in lines and numbers. The mind adds a quiet question that numbers do not answer by themselves. Is there calling here, or only curvature? The question does not accuse. It asks how purpose appears when physics is all that is promised. Brains are pattern engines. They compress the world into stories because stories travel through memory with less friction than tables. A surprise is a short story that refuses compression. When an unlikely alignment happens, attention spikes because attention is a detector tuned to rarity. Signal and meaning are cousins in this way. In information theory, a symbol that was hard to predict carries more bits. In felt life, a symbol that was hard to expect carries more weight. But weight is not proof. Surprise measures the mind. It does not yet measure the world. Physics writes against this tendency without erasing it. The second law of thermodynamics explains why time feels like an arrow. Low entropy in the past funnels histories into channels that create structure before dissolving it. Stars emerge, planets cool, chemistry climbs a staircase toward metabolism and thought, then thought looks back and names the staircase. Teleology is a word about intention. Teleonomy is a gentler word about the appearance of intention in systems that were shaped by selection and feedback. A comet's coma looks aimed because sunlight and spin make jets that point. A living cell looks purposeful because storms of chemistry were sifted by survival. The difference matters because purpose in the strict sense requires preferences that can be violated and remembered. Carbon dioxide does not prefer. A cell does. Einstein taught a taste for causes that are quiet. Geometry tells matter how to move, and matter tells geometry how to curve. The elegance burns away superstition until only relations remain. Hawking added a discipline for edges. Horizons are not mystical veils. They are places where information is delayed and rearranged. Together, these teachings place meaning in the relation between observer and observed, rather than in the observed alone. A beam of light is simply a solution. A measurement is a meeting where solutions are pared down by context into a fact. The difference between beam and fact is where meaning begins to grow. Across that boundary lives semantics. A signal that can change a choice carries meaning for the chooser. A syllable in a coma changes no choice unless a listener has a model that can be updated. Meaning, then, is not a property of gas. It is a property of a system that can revise its expectations. The tide of meaning rises where revision is possible. Telescopes change expectation by narrowing uncertainties. Minds change plans by directing resources toward what matters next. In both cases, the new course depends on the reception of structure. Meaning is not a halo added by romance. It is the algebra of practice. Still, poetry leans close for a reason. Humans are boundary animals. They stand between heat and frost, ignorance and inference, silence and speech. Old myths describe oceans that were called and mountains that were summoned. The modern narrative does not need a summoner, yet it keeps the posture of listening that myth rehearsed. Listening is a method. Listening is a mood. Listening allows weak signals to be kept safe until they are strong enough to stand alone. A culture that refuses poetry is a culture that throws away the cradle of patience. To guard the cradle, statistics becomes a guide. Suppose a sequence of events could be random or could be arranged. The proper question is not whether arrangement is beautiful. It is whether the arranged model compresses the data more efficiently than the random model without borrowing luck. A modest gain in compression is not enough when the model has many adjustable parts. Occam's razor lives inside the integral over those parts. The average success, not the peak success, tells whether structure has earned its food. In this view, calling is a hypothesis of low complexity with high yield. It must produce a short message that explains much. Otherwise, it is a word that warms the air but not the ledger. Anthropic reasoning offers a second compass. Observers exist only in worlds where observation can evolve. That fact selects environments where time has allowed stars to make metals, planets to cool, and chemistry to lose its fear of water. It also selects moments when tools are good enough to notice what passes near. To find oneself in an age of detection is no miracle. It is the only age in which a self can ask the question. The tide of meaning rises partly because the shore exists at all. There is a softer philosophy at work as well. Emergence is not magic. It is what happens when many parts interact so that new regularities become stable. Vortices in a river are not imposed from above. They appear and persist because equations permit them and because dissipation sorts possibilities. Life is a vortex in chemistry. Culture is a vortex in life. Meaning is a vortex in culture. None of these demands a plan. All of them permit the language of ends because they stabilize around outcomes that can be named. Science can accept that language as long as it remembers that the ends are local, not cosmic. Consider the way horizons in the mind mirror horizons in space. Knowledge has a light cone. Within the cone, data flow toward memory. Outside, speculation lives. As instruments enlarge the cone, facts overtake stories. But stories do not die. They become models. And models are stories that survived trials. In that arc, the sense of being addressed changes character. It migrates from hope to habit. A rare event becomes a test that sifts models by how quickly they learn. Quick learning feels like grace. Grace is only a name for the moment when a map moves closer to the territory. Meaning also inherits weight from cost. A measurement that demanded nights and failures is valued more than a number peeled from a dashboard. This is not irrational. Effort is a noisy proxy for difficulty. Difficult facts are rare. Rare facts move priors more. Minds use cost as a cue to importance, for the same reason foragers use effort as a cue to calories. The habit can mislead when effort reflects romance rather than traction. It protects against triviality when romance steps aside. There are mirrors inside mirrors in this subject. The conviction that there must be intention behind a pleasing fit can itself be an evolved taste. Taste favoured ancestors who saw patterns in rustling grass before lions struck. Haunted by that history, the present mind credits agency too soon. The correction is not to distrust all impressions. The correction is to tie impression to interventions. An impression that suggests a check that can be made tomorrow has dignity. An impression that shrinks under measurement is a story about the observer, not about the world. All this discipline might sound cold, yet the emotional register remains warm. A universe that writes structure without permission is already generous. It offers the chemistry of breath and blood. It offers the gravity that folds gas into stars that keep time. It offers metals that shine, and salts that dissolve, and photons that remember direction. The generosity is not a gift giver. It is a theatre where gifts and givers can arise. Seen this way, calling does not vanish. It changes tense. It becomes the echo of living systems inside lawful rooms, an echo that minds mistake for a voice beyond the room. Language can honour that echo without deception. The star invites because curvature gathers paths. The traveller answers because momentum meets a well. The watchers listen because curiosity eats entropy and leaves order in notebooks. Everyone keeps manners. Instruments refrain from exaggeration. Minds refuse to kneel before coincidence. Together, they build meaning that can be carried forward without apology. In the end, tides return to sea. The shoreline dries. The marks they left remain. A set of numbers that once felt personal sits in an archive and matures into precedent. Future listeners will come, and their tide will rise over other facts and leave other marks. Calling will be asked again, and again the answer will depend on how questions are shaped. It is enough that the shaping can be done with care. It is enough that wonder can be taught to pass through evidence and emerge brighter. Near the star, everything accelerates. Light doubles and redoubles with each small step inward. Heat climbs a staircase whose risers are carved in inverse square, and the traveller enters a theatre where seconds matter. Perihelion is not a point. It is a corridor of pressure and brightness, where materials answer questions they have postponed for ages. Gas meets the test first. The shallow crust, stitched by frost and organics, feels strain that runs along old seams. Some seams yield and become throats. Others seal under their own melt. Carbon dioxide may surge through the paths it long favoured, or its channels may clog as dust slumps into them. Water feels the deeper warmth and begins to stir in layers that have slept until now. If the ladder of temperature reaches far enough, the voice of the coma changes register. Light curves reveal the decision without asking. A slow crescendo that peaks slightly after the moment of closest approach betrays a thermal lag in which heat sinks past the day skin and recruits deeper ice. A sudden spike with a fast fade suggests a fracture that sprinted across a roof, vented a cavity, then choked on its own rubble. A plateau implies many small vents adding up to a steady choir. The cadence can break, too. Outbursts carry profiles like lightning, thin at the rise and long at the fall, and they write asymmetries into the dust that remain for days, as a fan that refuses to align with the simple antisolar line. Jets evolve into geometry. Near the star, a faint breeze of gas becomes a wind, and the wind turns narrow throats into visible filaments. Sunward plumes can appear as shells, arcs that are really cones seen in projection. Tailward plumes stretch into streamers where particles sort by size. Small grains follow gas and write soft brushstrokes. Larger grains lag, draft through the coma, and spray into wider sheets that remember the rotation of the source region. Synchrones and syndynes, the families of lines that separate time of release from particle size, intersect into patterns. An attentive eye can read like contour maps. Non-gravitational forces grow teeth. Thrust from gas no longer measures as a whisper in the orbit alone. It talks the nucleus and changes the clock of rotation. Spin up is common when jets cluster on the afternoon side. Spin down emerges when vents prefer dawn. If the spin period shortens enough, cohesion competes with centrifugal stress and the surface sheds at its weakest ridge. Fragmentation can be silent, a flock of pearls gliding near the head that slowly drift apart, or it can be violent, a sudden brightening that masks a shower of blocks. Either way, the gravity field rewrites itself, and vents that were steady switch off while new ones ignite. Spectra repaint their balances. Hydroxyl grows confident as water takes the stage. The green and red oxygen lines adjust their ratio as photodissociation changes parents and quenching relaxes with distance from the nucleus. Carbon dioxide's signatures can either hold or retreat, depending on whether its channels have survived the crush of dust. Line widths widen as outflow speeds increase in the warm gas. Velocity dispersions that were once tens of meters per second become hundreds, a sign that molecules leave with more energy and that collisions near the surface have a new regime. Dust brightness becomes immoral. If the mantle fails broadly, reflected light rises in step with gas production and tails thicken. If the mantle tightens and gas slips through capillaries that are too narrow to lift grains, the coma remains lean. Polarization curves tilt with the change. Compact grains expelled from crack mouths polarize differently than fluffy aggregates loosened from terraces. A quick swing in the curve over a few days tells of a new size distribution entering the flow. Sodium, liberated from small particles by heat and stress, can erupt into a slender ray that refuses to curve with the dust, a narrow filament that speaks of atoms pushed by light alone. Magnetism writes its own drama downstream. The tail of ions drapes around the solar wind like a ribbon around a stick. Near the star, that wind is busier, braided by shocks and ripples. A coronal mass ejection can hit and cut the ribbon, a disconnection event that tears the ion tail free at a bright knot and lets it drift away. The cut is clean in images. One moment, a continuous blue blade runs from the head to far downwind. The next, a gap opens and a new blade begins. Such surgery is weather, not will, but it adds punctuation to days already full of syntax. Thermal inertia declares itself in the rhythm of heat. Low inertia keeps warmth pinned to the skin, so activity peaks near local noon and retreats into dusk. Higher inertia moves the peak into afternoon or even evening on the nucleus, giving jets a consistent lean and adding harmonics to the rotation signal as hotspots refuse to align with simple angles of sunlight. A small change in inertia across a boundary between terrains writes two different clocks into a single light curve, an ambiguity that only spatially resolved spectra can untangle. Radiation stress tests the architecture. At small distances, sunlight forces delicate membranes, volatile frosts, and dust bridges to choose between integrity and failure. Plates that held through gentle seasons can spall. Cliffs can carve, sliding arcs of shadow across active ground, and choking vents until new paths form. These avalanches carry no atmosphere to slow them. Grains hop and settle in ballistic parabolas, then sinter anew, sometimes freezing jets mid-sentence and redirecting them with a single collapse. The coma answers immediately, and photometry catches the shift as an offset in phase or a step in amplitude. The nucleus itself can change color subtly. Freshly exposed ice brightens a patch and cools it by sublimation, while older, radiation-processed dust darkens and warms. If rotation brings both into view within an hour, the spectral slope across the visible and near-infrared slides between two moods, one pale and flat, one red and inclined. A watchful sequence through several turns of the body maps those moods to longitude, and by matching them to the timing of jets, geography becomes chemistry. Perihelion does not guarantee clamor. There is a path in which heat compacts the mantle, seals pores with resublimed frost, and actually quiets outgassing near the peak of light. In that path, brightening stalls and curves flatten. Silence at closest approach may be the most eloquent result, a verdict that the surface has learned to keep its reservoir until deeper warming or structural failure pries the locks. Post-perihelion brightening then becomes likely as the seasonal wave reaches the hidden shelves on its way outward, an echo of heat that arrives after the star is already receding. Dust trails linger as a final signature. Large grains released near the turning point follow paths that stay close to the orbit, forming a faint thread like smoke that refuses to disperse. Months later, that thread can still be seen by instruments built for low surface brightness. Its position angle and brightness profile record the timing of the release and the sizes of the grains. For a traveler that will not return, the trail becomes the only remnant in the inner system, a thin handwriting on the blackboard that explains how and when the chalk snapped. What happens in this brief corridor depends on thresholds. Small differences in conductivity decide whether water wakes. Small differences in cohesion decide whether cliffs fall. Small differences in vent geometry decide whether thrust points outward or sideways. The star supplies power and schedule, The traveller supplies structure and memory. Between them, brightness or silence emerges. To witnesses at a distance, the choice appears as a curve on a graph and as a shape in a tale. To the traveller itself, it is only physics speaking through porous stone. Distance replaces detail. The glow thins. The head shrinks to a point, then to a number, then to silence. The tail loosens until only a faint wash remains in long exposures, a scarf of brightness at the threshold of belief. Measuring continues after sight is gone. Astrometry once taken nightly becomes a ledger against which models are tested until residuals flatten. Photometry that danced with rotation is folded and subtracted to reveal what remains steady beneath the strobe. Spectra taken across many dates are weighted and combined into time series where the last line is a horizon rather than a destination. The outbound orbit settles first. A fit that honoured every centimetre of bias in the sensors converges to a vector. The speed at infinity is read with a patience earned by months of small corrections. The outbound asymptote points to coordinates that will slowly drift as the star moves through the local flow, yet the drift is a future someone else will measure. Deflection by the star and by the planets becomes a closed chapter. The energy balance reads as it should. The traveller is free again. What is left to learn lies not in direction, but in what was shed along the way. Dust remembers the chronology of its release. Late images with deep stacks show a thin thread near the orbit, a trail written by large grains that felt little of light's push. Along that thread, brightness maps to a clock that counts backward toward the day of heat. Models invert the geometry and find peaks that correspond to hours when vents were most open. The inverted peaks place longitudes on a map of an unseen surface. The unseen gains shape by implication. Fast particles are gone. The slow ones keep the record. Gas leaves a second ledger in production curves that were once just nightly headlines and are now history. Integrating those curves yields the total mass of volatiles given to the void. The numbers are ordinary in size for a small world, and extraordinary in their consequence. The partition between carbon dioxide and water, between parents and daughters, between pre-dawn flares and afternoon steadiness, between days when pressure won and days when crust held, all add up to a budget of energy and mass that a thermal model must balance. The model, tuned by months of data, returns an interior with layers that conduct poorly and pockets that vent along prepared seams. Spin leaves its own trace. A rotation that drifted by minutes suggests a torque that acted longer than any single jet could maintain. Inverting that torque with the measured gas loss yields a lower bound on size and an upper bound on density. Those bounds are candid about their uncertainty, yet they refuse to move past certain lines. The traveller is not a monolithic rock. It is not a fragile cloud. It is a porous body that could be lifted by a hand if only hands could hold vacuum and cold. This is not romance. It is arithmetic dressed in dust. Non-gravitational acceleration, once a curiosity measured in changes of residuals, becomes a constraint on geometry. Acceleration vectors that rotated with a certain phase anchor, active longitudes and suggest obliquity. The best fit respects neither perfect symmetry nor perfect chaos. It tells of a few persistent chimneys among many silent ones. It tells of a surface that listens to sunlight more than to whim. The outbound arc would have been cleaner without these pushes, yet their presence is a kindness. They are signposts left by breath. Thermal emission in the mid-infrared, combined with reflected light in the visible and near-infrared, fixes an albedo and a thermal inertia to within bands narrow enough to guide future experiments. The albedo is dark but not black. The thermal inertia is low enough that afternoon heats deeply only by degrees, not by leaps. These two facts tell a lab what to build. Mixtures of ice and dust are packed to that inertia and baked to that albedo. Gas is allowed to find its way through pores the size of the numbers in the fit. Some samples crack as predicted. Others refuse. The ones that refuse are reminders that models learn by failing forward. The ion tail, once a banner, leaves a profile of the solar wind along a line the traveller stitched through space. Disconnection events, recorded at dates and times when the wind was busy, become timestamps on the star's behaviour carried outward by plasma waves. These footprints are not the purpose of the chase, but they are part of the inheritance. A comet can be a magnet for heliophysics, even when its nucleus is the headline for another field. Population changes by a fraction. Rates are updated. The mean interval between such visitors, conditioned on the depth and cadence of surveys, is nudged. Priors shrink. Proposal language becomes cleaner, less apologetic about opportunity, and more practical about readiness. Pipelines change thresholds in quiet commits that matter more than press releases. The string of 3 entries in a small catalogue becomes a line long enough to talk about slope, rough enough that caution still rules. A distribution on speeds and on volatile ratios acquires thinner tails. Wide beliefs become narrower and, paradoxically, more hospitable to surprise, because surprise is now better defined. The outbound vector will not cross human paths again. That is a gift in disguise. It leaves analysis with a firm ending. Teams archive raw frames and calibrated products with care, because deep time must be a collaborator. Formats are documented, pipelines are versioned. Caveats are written like marginalia in a manuscript that someone else will someday annotate. The trace is preserved not only in data but in the manners of a community that has learned the courtesy of permanence, meaning adjusts itself to fit the evidence. The traveller did not teach by proclamation, it taught by forcing models to choose specifics. A capillary network can or cannot pass water at a given temperature. A fossil rind can or cannot make carbon dioxide lead the song when morning comes. A primitive interior can or cannot supply enough mass to explain a season. Each cannot that became a can is a rung in a ladder someone else will climb when the next rare point lights up a screen. Questions remain. They always do. Did a subsurface phase change contribute to a certain flare? Did a vent jam by frost or by collapsed dust? Did the spin precess in a way that geometry only half explains? The trace cannot answer every question, and that is not a defect. It is the invitation for a future measurement that will be designed with these questions in mind. Designs sharpen when they are turned towards specifics. Ambition becomes precision only in the presence of a target that said enough to matter and not enough to satisfy. The night resumes its ordinary stars. The memory of a moving point is now numbers, plots, and models that correspond to something that is already far beyond the orbit of the outer planets. It leaves behind a changed posture. Instruments will turn earlier. Schedules will flex more. A box on a shelf filled with pre-built parts for a quick chaser mission will be checked more often. A keyboard macro that once rejected certain motion patterns will now let them live long enough to be judged by a human eye. The trace is in behavior as surely as it is in light. There is a final sentence to write, and it has no verbs that claim more than physics permits. The traveller came because paths exist and gravity bends them. It became visible because instruments were ready, and light cares little about pride. It left a trace because minds kept the record. That is enough to fold into a quiet gratitude that does not need to be louder than a coma. The gratitude will last longer than the dust, which already loosens into the dark. Night keeps its promise. The sky breathes in, and the faint smear that once carried a rumour of fire has gone to distances that no city can imagine. What remains sits in folders with names made of dates, in curves that look like tides collapsed into ink, in tables where numbers balance like stones along a riverbank. A reader leans in. The pages smell of cold glass and late coffee. Somewhere a dome turns to morning with a slow sigh and locks its shutter. Somewhere else a line in code that used to say ignore now says consider. There is a grace to what has happened. A body without intention crossed a small nation of instruments, and together those instruments learned a new patience. They learned that silence can be a finding, and that brightness can be a form of restraint. They learned that ratios whisper where images shout. They learned to trust intervals as much as peaks. The world that watched learned something too. It learned that wonder breathes better when it admits to limits, and that mystery survives measurement not by retreating, but by changing its clothes. The road between stars is not empty. It is thinly peopled by fragments that remember different suns. Some will pass far, some will pass near. A few will light the hardware that waits in cold storage and test the vows that were made on quiet nights. In that sense, the next visitor has already shifted the angle of a mirror by a fraction no one will notice until it matters. Readiness is a form of affection. It says that attention will be paid when the small and rare decide to cross the stage again. If the thought returns that something called, let it be translated into the language of curvature and chance, If the ache persists for messages, let it search in discipline for patterns that survive correction. If no such patterns appear, let the ache turn into a softer gratitude, the kind that watches a tide cross the flats and does not ask to be named. The tide, after all, is enough.